Yes, everyone. So our participants have got some queries. Yeah, audio or the sound was switched off because we are going to start now. I hope the sound is clear. Kindly inform us through your answers if there is any issue. And we shall initiate the proceedings of opening the International Faculty Development Program organized by the Department of Information Technology and Engineering, Amity University in Tashkent, Uzbekistan. We have our participants from different countries, from different universities, as well as from industry. There are researchers as well. We welcome everyone, and we shall be proceeding ahead to open this FDP with a formal opening and welcome remarks for everyone from the head of the Department of Information Technology and Engineering, Amity University in Tashkent, Uzbekistan. I request Professor Dr. Praveen Kumar, Head, DITE, Amity University in Tashkent. Sir.
Yeah, thank you, Praveen. Thank you for invitation. So good afternoon to one and all. In motivational presence of our director, Mr. Babar Abdullayev, and Deputy Director, Dr. Naina Chaudhary. On behalf of our Honorable Founder President, Sir, Dr. Ashok Chauhan, respected Chancellor, Dr. Atul Chauhan, Sir, respected Trustee, Mr. Amol Chauhan, Sir, and Group Vice Chancellor, Professor Dr. Gurinder Singh, all faculty members and staff of Amity University, Tashkent, Uzbekistan. I welcome you to the one-week faculty development program on the smart future technology in AI, ML, and data analytics. Friends, AI is dramatically changing the way the world works by making machines that are programmed to think like human and mimic their action. The influence of artificial intelligence technologies on society and human beings have been strong. The number of applications of AI is increasing and the AI research field is expanding. The application of AI range from speech recognition, problem solving, learning, planning, and many more. In this direction, Amity University Tashkent intends to organize one-week faculty development program on smart future technology in AI, ML, and data analytics from 3rd April to 7th April. The idea of this FDP is to make the participant aware of the advanced artificial intelligence fields. The FDP will comprise of the essential theory with hands-on experiments on different technological developments by the experts from academic institutions as well as from industry. This will improve the quality of teaching, which will motivate us to take up the challenges of the modern world. And also, I'm happy to share that we got registration from 22 countries. Thank you. Thank you and all the best.
Thank you, Professor Dr. Praveen Kumar, Head, DITE, Amity University in Tashkent. Now we have the privilege to invite Dr. Naina Chaudhary, Deputy Director, Amity University in Tashkent, to kindly deliver her welcome address and motivate us. Ma'am.
Thank you. Thank you, Mr. Parveen. You can stop sharing the screen.
Sure, ma'am.
Thank you. On behalf of entire Amity family, I would like to welcome all the attendees and panelists. It was very overwhelming to know the number of faculty all across the globe who registered and showed interest in this faculty development program. It is a great initiative by the department, and especially Dr. Praveen, who's heading the department, to bring in some best brains from industry, academia, and research. Because there's nothing better than peer-to-peer learning, and the faculty members of today's age did not have the formal education in artificial intelligence and deep learning because it is very recently after Industrial Revolution 4.0 that we heard of these jargons, and they were very new to us, but now they look quite inseparable from our lives. I am very happy that with your knowledge and experience, our faculty will be enlightened and the whole community will get a hands-on experience and learning of these emerging technologies, especially after COVID. The world has seen how we have moved from the physical mode to, it is only the technology which could keep the whole cycle of life alive and the whole system goes on, and the economy didn't just collapse. It is only because of technology that the education was going on, teaching learning was going on, and things were moving. So this is something that is really great. I believe, Dr. Praveen, you've taken a great initiative, Dr. Seema and Praveen, who all were involved. My best wishes for the organizing team, and I'm looking forward to a great learning experience for next 5 days. I welcome Dr. Ajanta.
Thank you.
I have read your profile, and I am quite impressed. I'm seriously looking forward to
Thank you. Thank
the
you.
knowledge that you are going to share with all our attendees. Thank you so much.
Yeah, thank you.
Thank you. Thank you very much, ma'am. So now we are inviting our director, Amity University in Tashkent, Mr. Babur Abdullayev. Sir, we are privileged to have you and wish to request you to please deliver your motivational address to all of us. Sir.
Thank you so much, Dr. Parveen. Good afternoon, everyone. We're very happy to see all of you here today. On behalf of entire Amity family, we are greeting you, all of you, every participant, every attendee here. I'm sure that we'll get a lot of very useful information and a lot of new thoughts, new ideas on the topic, which is very important for me also, and for everybody gathered here. Smart future technologies in artificial intelligence, machine learning, and data analytics. What a great topic. I would call these things as a revolution, because when the people invented the electricity, revolution came and changed a lot of things. Internet did the same, and now it's time for the AI and machine learning to do it. And we're here to understand the future technologies. And I'm sure that during these 5 days, we'll get a lot of new ideas and new inputs for the topic. And what a great speakers we're having. Dr. Ajanta, we welcome you. I'm sure that we'll be able to welcome you in Tashkent also physically, but always great to have you online also.
Thank you.
And great initiatives from our department, headed by Dr. Parveen and Dr. Seema, and Dr. Parveen is always here to catch up and do lots of great things. I'm very happy to see all of you here. And I'm sure that this program will be very useful for all the participants around the globe, participants from more than 20 countries. And this is the great part of Amity, that we are trying to connect everybody from all around the world to come together to solve the issues, to make the great future together. Thank you for all the organizing team, guests, and keynote speakers, and Dr. Ajanta, Dr. Nena also. You are doing a lot of things to make it happen. We one more time welcome you. Thank you.
Thank you, sir.
Thank you very much, sir. And yes, Amity always focuses on the constant development of skills, be it the part of students or be it the teachers. So here we move ahead to the special part of this FDP, when we are going to introduce our resource person of the day, and we are going to have her deliver her knowledgeable session to all of us. So this is the list of resource persons that you see on the screen. But today we have to open Dr. Ajanta Devi, Research Head, AP3 Business Solutions India Private Limited. Ma'am, we have the privilege to have you, and we welcome you on behalf of all the participants and the complete Amity fraternity around the world. We wish to introduce you to our participants before you begin your session. So everyone, Dr. Ajanta is an expert in the area of machine learning, deep learning, data structure, digital image processing, speech processing, pattern matching, and many other domains. She is a senior member of IEEE and a reviewer with more than 6 international publications. She has more than 15 years of experience in research and academics. She has 6 patents to her credit. There are around 50 research papers and more than 13 book chapters published by her. She has won the Best Paper Award 5 times. She has delivered invited talks at more than 50 conferences and workshops around the world. She has also been conferred with multiple awards at the national and international levels, including CIEMA Research Excellence Awards and Social Responsible Researcher Republic Day Achievers Award, to mention a few. Her research collaborations have been with King Faisal University, Saudi Arabia, DST India, and many other organizations. Dr. Ajanta, we welcome you in this international FDP and invite you to kindly deliver your resourceful lecture session to all of us. Ma'am.
Thank you. Thank you for the opportunity.
Ma'am, you can share your screen if you are willing to. Yes, ma'am. We'll confirm.
Yeah, of course. Are you able to see my screen?
Yes, ma'am. We are able to see. I hope participants are also able to see this. Thank you very much, ma'am. Over to you, please.
Thank you. Thank you a lot. Thank you. Yeah, happy afternoon, dear friends, and here with the first sessions of this FDP. Really happy to be here and being always Praveen sir and Sima ma'am just say me just you're the opener, of course, opening batsman. So thank you for the opportunity. Actually, here, see, I'm well on to the very patient on to having the knowledge sharing. So it is my passion to be here, and of course, happy to be starting the first session of this FDP. Yeah, let me just go, dear friends. Can I be able to have some yes? Are you able to see my screen, or am I audible? Can I hear some yes? Of course. Yes. Yeah, thank you, dear friends. Fine. So here is the one we are just going to discuss today. Is all about natural language processing. And of course, yeah, let me just start with some natural language processing, and towards that, how it is on in the field of deep learning too. Yeah. Natural language processing is one of the hottest area of artificial intelligence, actually, thanks to applications like text generators is that composes coherent essays, or chatbot that fool people into thinking they are sentient, of course, is there. And the text-to-image program that produce photorealistic images of anything you can describe. And recent years have brought a revolution in the ability of computers to understand human languages and programming languages, and even biological and chemical sequences also there. And of course, AI models are unlocking these areas to analyze meaning of input text and generate meaningful expressive output. And dear friends, this one you have already known, of course, coming to this AI era, this one is always familiar. Of course, artificial intelligence is how we just specify. Humans have long been obsessed with this creating AI ever since the question can machine think, or which we just say Alan Turing in 1950s. Difference actually, AI enables the machine to think. That is, without any human intervention, the machine will be able to take its own decision. It is a broad area of computer science that makes machines seem like they have human intelligence. So it's not only programming a computer to drive a car by obeying traffic signals, but it's when the program also learn to exhibit the signs of human-like road rage. And coming to this machine learning, it is exactly a subset of artificial intelligence that uses statistical learning algorithm to build systems that have the ability to automatically learn and improve from experiences without being explicitly programmed. Most of us use machine learning in our day-to-day life when we use services like recommendation systems on Netflix or YouTube or Spotify. Okay, search engines like Google or Yahoo, or voice assistants like Google Home and Amazon Alexa. So in machine learning, We train the algorithm by providing it with a lot of data and allow it to learn more about the processed information. Of course, we already come to that, that is ML algorithm can be broadly classified into supervised, unsupervised, and reinforcement learning. Coming here to the deep learning. Of course, deep learning is a machine learning technique that is inspired by the way a human brain filters information. It is basically learning from examples. It helps a computer model to filter the input data through layers to predict and classify information. Difference actually, deep learning process information in a similar manner as a human brain does. It is mostly used in applications that people generally do. It is a key technology based behind what we just say as like driverless cars that enables them to recognize a stop sign and to distinguish them or distinguish between a pedestrian or a lamppost. So most of the deep learning methods use neural network architecture. So they are often referred to as a deep neural network. And of course, even in the introduction also, we have just heard that deep learning is also one among the mimicking the human brain. And it can also be defined as a multi-neural network architecture. And that comes now towards our topic, natural language processing. How does this natural language processing fit into the AI world? So can I get some answer whether this natural language processing comes under machine learning or deep learning? Now here we are in deep learning. Of course, it's known, dear friend. Yeah. How it just started? Yeah, of course. Yeah. Any idea? Yeah, of course. Yeah. Thank you, Ankita, ma'am. Actually, with a basic understanding of this artificial intelligence, machine learning, and deep learning, this neural network are sometimes used almost interchangeably. However, there is an order to the madness of their relationship. Of course, we already known to this. And yeah, coming to this hierarchy, there and natural language processing is considered as a subset of this this part of this artificial intelligence or machine learning and deep learning, where we just combine a computational linguistic behind to this. And actually, this natural language processing empowers computer programs to comprehend unstructured content by utilizing artificial intelligence and machine learning to make a derivation and give context to languages like that. Similarly, as human, what we just do. Okay, and of course, it is actually it is an one thing which we just say, that is the field of the study which we just focuses on this computational linguistic combined to all this artificial intelligence or machine learning or this deep learning, which we just say and interactions between human language and to the computer. And yeah, of course, it sits at the intersections of computer science, artificial intelligence, and computational linguistics. Coming to this today's content. Yeah, dear friends, today we are just going to have some introduction related to the natural language processing, and we are just going to have a hands-on on the text pre-processing and text to futures. And yeah, let me just have some discussion related to what are all the future tasks there in natural language processing, at most current trends in machine learning and towards deep learning also. And let me just discuss some libraries. Here comes, dear friends. So natural language processing is the discipline of building machines that can manipulate human languages or the data that resembles human language in the way that is written or spoken and organized. And it evolved from computational linguistics, as I have already specified. So which uses computer science to understand the principle of language, but rather than some theoretical framework, NLP is an engineering discipline that seeks to build technology to accomplish useful tasks. And yeah, so here how we just make an input. So if we just give text data as an input, yeah, of course, it is just going to be as a pre-processing, and next it is the exact flow of passing the text and towards the exploratory data analysis. Then next comes the future engineering. Towards it, build with some models. And lastly, we are just going to evaluate the performance by deploying it. And so, of course, we have already seen some introduction. So this NLP helps developers to organize and structure knowledge to perform tasks like translations, summarization, and named entity recognition, relationship extraction is there, and speech recognition, topic segmentation, etc. So many things are there, dear friends. So before we learn how NLP works, let's understand how humans use language. So here I'm just given two examples is there. See here, dear friends, every day we say thousands of words that other people interpret to do countless things. So we consider it as a simple communication, but we all know that words run much deeper than that. There is always some context that we derive from what we say and how we say it. So natural language processing in artificial intelligence never focuses on voice modulation. It does draw a contextual process. So here, so kindly just to see onto the first example, man is to woman, as king is to what? So king is to what? Of course. Can I get some answers so that it would be somewhat interaction? Yeah, of course, queen. Thank you, Felicia. So actually, so how this came into, so see here, dear friends, so man is to woman as king is to queen. So here we can easily correlate because man is male gender and woman is female gender. In the same way, the king is masculine gender and its female gender is queen. Of course, we just got the exact answer in the same way. So now looking on to the second example, is king to kings as queen is to, what would be the answer? Yeah, of course, queens. Here we can see two words, kings and kings. So where one is singular, other is plural. So therefore, when the word queen comes, it automatically correlates with the queens and towards the singular plural combination. So here the exact correlation it is between the plurals, and where the example one it just came into as an gender relationship. So that is how this machine would just come into understanding. And with this example, now let me just have some examples on how the exact machine understand behind this, how the machine understands. When not just see, actually, a very big question is that how do we know what words means? Easily we can just say king or kings or queens like that. Now, who will call it as a queen? How this word would just mean to the machine? The answer is we learn these things through experience. So, however, here the main question is how computer know about the same. What we are just going to do is, of course, we are going to feed the machine with the entity related with the queen. So kindly just see here Her Majesty the Queen's features, or the crown of the Queen Elizabeth, the Queen's mother, the Queen is gorgeous. So these are all the exact words or the sentence that would just make an example that my machine understand about the entity queen. So this is how each and every entity or a word that would be understandable to make the machine to get it understand. And coming to this, dear friend, here, each and every machine, that exact the machine, when you just feed onto that example, it just creates a vector. Here, as it learns from multiple data sets, yeah, of course, it just uses machine learning or deep learning algorithm. A word vector is built using surroundings the words. And when we just say here for an example, king or as like a man. So here meaning when we just go for the example of the one. So here when we just relate it to the gender, yeah, king is the male and queen comes to the female. And of course the same princess and princes. So the same thing it just comes. And when on to the amount performing some algebraic operations also, we can just take it as like, yeah, king, that is towards the royal. And if we just go towards that non-royal, it just comes the minister. So this is all the exact combination of a word and towards the vector where a machine would just get understand by the exact sentence it just receives. So what we just speak it to our daily life. So here is the one, a main functionality, that is the component of natural language processing, which is just divide it into the subfield as understanding and the generation. And kindly just have a note of it, dear friends, where now we are in the trends of natural language generation. Of course, all the thing which we just come across nowadays as in ChatGPT or Google AI, whatever be, it is under a generative text processing. So yeah, of course, see here this natural language understanding, which focuses on semantic analyzation or determine the intent meaning of text. And here natural language generation, which focuses on text generation by a machine. And here NLP is separate from, but often used in conjunction. Yeah, even though you can just take it into as like speech recognition or what is the spoken language that we just converted into words or like that. And of course, dear friends, when coming to this natural language understanding, here we have the lexical ambiguity is there, syntactic and referential ambiguity is there, which is just take as a lexicon or parser and grammar rule, where here semantic theory that just guide towards the comprehension. Well, coming to this generation, actually, it is the concern with generating natural language. So it uses the machine representative system like a knowledge base or a logic form. You can think of it, it is as a translator between data and natural language representation. And of course, it is exactly opposite to natural language understanding. And I'm coming to the exact same here. This natural language generation involves three types of tasks, as like text planning and sentence planning or text realization. But text planning, it is what we just said, to extract a relevant context from the knowledge base. And sentence planning, of course, to choose appropriate words from meaningful phrases and just to set some sentence tone. We're coming to this text realization. It is just to map the sentence plan into a sentence structure. So here, these are the exact standard is that, dear friends, where we just come across the component. And next comes the main steps of natural language processing. Here it is the exact flow of the morphological, lexical analysis, which is just takes the vocabulary that includes its words and expression. It depicts analyzing, identifying, and description of structure of a word. When coming to the semantic, it just focuses only on the literal meaning of word, phrases, and sentence. Actually, this is only an abstract. So the dictionary meaning or the real meaning of from the given context. And if we just say, for an example, a colorless green idea, this would be rejected by the semantic analysis as a colorless. And here also there is a green, so it doesn't make any sense. And when coming to semantic, it is a structure created by a syntactic analysis, so which assigns meanings. So this component transfers linear sequence of words into structures. And next comes the pragmatic analysis, which deals with the overall communicative and social content and its effect on interpretations. So it means abstracting or deriving the meaningful use of language in the situation. So if we just say, close the door or close the window. So if we just specify that, so they interpreted as a request instead of an order. So if we just say, would you just close the door? So that would be something, whether is it a request or whether it is an order. So it just means whether how the exact pragmatic it would be analyzed. And last but not least, about the discourse integration. Actually, it means a sense of context. So the meaning of an single sentence which depends upon that sentence. It also considered the meaning of us, like which we just say, he wanted that. What is that? So that exact word we would already given somewhere previously. So maybe book, or maybe something in order, or something in a delivery package or something. So we have already given some description about that, and we are specifying here according to he wanted that. So it depends upon the prior discourse or context. And here we go, dear friends. So let me just start with some hands-on. So before going on to that, I just want to give you a small brief related to what is text pre-processing. And this is the main, and whenever we just apply onto any natural language processing, of course, we have to know what is the exact input text and what is content. And with that one, we are going to process it. So of course, let me just take it into the context. So text is the most unstructured form of all the available data. So various types of noise are present in it. And data is not readily analyzable without any pre-processing. So the entire process of the clean and standardized of text, making it noise-free and ready for analysis, which we just say as text pre-processing. And here it's just going to include noise removal or recursion normalization and object standardization. So these are the predominantly comprised of 3 steps, that is the pre-processing. So once on going to this noise removal, see, as any piece of text which is not relevant to the context of the data and end output, we specify as a noise. So for an example, if we just say, so here I have already specified. So for an example, a language stop word commonly used as like is, am, the, of, in, like, etc. Excuse me. So, or even though as like URLs or links or social entities, social media entities, as like mentions or hashtags. So these step exactly, that's noise removal step would deal with removal of all these types of noise entities which is present in a text. And general approach of this noise removal is to prefer a dictionary of noisy entities and integrate the text object by tokens. And next, that comes the lexical normalization. Of course, dear friends, this is another type of textual noise is about the multiple representation exhibited by a single word. And for example, if we just take a word as like play or playing, what does that mean, that playing? So here the exact root word is all about play. Though they mean different by contextual or all similar as like play or player, played, playing, play. So what is the exact step of this normalization? It is just converts all the disprites of a word into their normalized form. Also, we just say it as like a stemming or lemmatization. And the stemming is which we just specify as like a rule-based process of stripping the suffix. And lemmatization, on the other hand, is the organized and a step-by-step procedure of obtaining that exact root form of the word. And there next comes the object standardization. And here, as we just say, so text data often contains words or phrases. So which are not present in any standard lexical dictionary. So some example are like acronymy or hashtags with attached words and colloquial slang. So with the help of regular expression and manually prepared data dictionary, this type of noise can be fixed. So here I just want to show you a small hands-on to this. Kindly have a note of this. So is it able to view, dear friends? Yeah, can I hear some yes? Yes, yeah. Thank you, dear friends. So see here. So when we just take a word, when we just take, of course, a sentence, what this word tokenize would just do. So here, of course, we are having a sentence as like the quick brown fox and jumped over the lazy dogs. So if this is the exact sentence, of course, the word tokenization, it is exactly would split the text and it just makes us processing. So it just makes the processing, of course, by removing the noise, and it has to be small, normalized and standardized. So let me just take it into the exist of first one. So let me just do something with a normal functionality. So here, text dot split is the function we are just going to apply. And let me just see here difference. So of course, each and every word has been tokenized. Every word tokenized is in the sense, every word is split into separate element. Now, is it possible for every set of element? Of course, let me just try. Here, one of the example is that I have just given it with a comma. So kindly observe here. So if it's possible by the same regular splitting, so let I just execute it and see here difference. This comma has been prefixed with a comma. So this word fox has been prefixed with a comma. So of course, it is not tokenized perfectly. So for this, what we have to do, of course, we have to use a toolkit for this natural language processing. And here I have just given the command. And if you are not having the natural language processing in your system, kindly you can just have a download of this natural language processing by using this command. And of course, here I'm just going to import the module word tokenize from the NLTK toolkit. And kindly now observe, I'm just going to use that word tokenizer. And here, let me just use this method towards the tokenizing. That is, tokenizing is splitting the text. So here, observe it. Yeah, of course, the comma is now separated as a separate element in the token. And kindly just, dear friends, I just let you know this tokenizing. What it just do is behind the scene, it just makes the splitting the sentence and it just gives us like each and every element as in a list. Now, of course, not only this, let me just have some more example. So here I have just taken one more text, and here what I just need is, it is a tweet from a tweeter. And here, of course, see, not only the comma, here there are so many symbols are also included in this text. So when I just make use of the same word tokenizer here and observe the exact result. So here, the exact symbol has been separately tokenized. The at symbol that has been separately tokenized, that is separate element has been done. And to the shocking, the smiley has also been done. And you know that exactly the smiley word would also have an meaning. Meaning, of course, under emotional intelligence, of course, each and every smiley, whether it is happy or it is sad, of course, each and everything there is an meaning among these tweets. So we have to use particular tweets towards this tweet text. So that is the one, of course, dear friend, here it is the one, a model called tweet tokenizer. So by using the tweet tokenizer, yeah, we are going to include it towards the model, and when on applying onto this tokenizer, and observe here, dear friends, yeah, now this gives you a meaning of hashtag. And these meanings, of course, it just comes towards it. And yeah, we just got the smiley. So each and every word, there is a meaning towards it. So how we speak, how we give an importance towards our text, our modulation, our meaningful things, all that, of course, it is also we consider that in the natural language processing toolkit. Now coming to the one, yeah, here you are also having one more option. Yeah, if you don't want to have this handle, yeah, you can also strip it by providing this attribute. Yeah, now we just got only the tweet and about and with the hashtag as one among the keyword, and last not but lastly, smiley too. And kindly have a note of it, dear friends. So yeah, of course, not only there is a tweet or there with the keywords or with the text or with the special symbols of like a hashtag or comma or thing. Yeah, of course, there is an importance for the currencies and towards the date. So here it's so, yeah, we can include the currencies amount, whether it is a dollar or pounds or euro. Yeah, of course, you can include it. And here one among the examples for the date, 19th September, 18th September. So that exact things would also be included. And of course, it gives us a meaningful text. And kindly just observe, dear friend. Yeah, here we are getting it with the currency, and of course the date, it is prefixed with the exact term. So this is how. So yeah, of course, the parenthesis has also been separated as an element here. Open parenthesis, close parenthesis. Yeah, it's there, and of course, kindly just to see this currency, it just has a dot and to a comma. Now it is separate. It is not as separated. It just gives you the value of the currency exactly and to the date. And coming to the next content of the pre-processing, yeah, we are here towards normalization. Dear friend, kindly just observe here, yeah, as I have already said, stemming is one among the rule-based process for stripping the suffix. Of course, we have to include the keyword, the module for this. And when on just inclusion of this module, yeah, we can just get the exact root word. So here we are going to give you some example as like having, have, and had. So one's on need of this root word. So kindly just observe the first one. And second example, yeah, here we are having the fishing, fish, fisher, fishers, and fish. And for your surprising, I just to show you the execution output. See here, dear friends, this having has been stripped out, and here we just got the word have, of course, but not this had. Actually, this had, it is all about the past tense, but it never converted it towards the root word. And next to that, here I have just given fishing, fish, fisher, fishers, and fish. Apart from this fisher, all the other, yeah, it has been stemmed. That is, it has been stripping the suffixes with the rule-based process. It just done. But one among the fisher, of course, it doesn't do it because of the professional. It is exactly the work, the fisher. So it didn't do it. Yeah, next coming to the lemmatization. Yeah, here I have already specified. This produces a normalized version of an input word. And here, this exact lemmatization, it is all according to the part of speech, where we just have a tag of POS with whether it is a verb or noun or etc., whatever we are just going to do. And of course, dear friends, kindly have a note of it. If you are in need of this exactly, you have to download this. And here I have just given the module, where this module, it just make use of this lemmatization. And the above example here also, I'm just going to show the same. And see here, dear friends, having with a part of speech tagging, I'm just giving verb, and have, that is the verb, and had, of course, verb. And here towards the fishing, fish, fisher, fishers and fished. Here for fisher, I have just given you the exact tagging of noun. And when on observing this, kindly just have a look of this, not only towards the functionality. Here I have also added to that am, is, and was. Yeah, if, of course, you would just view it in the resultant. Kindly just observe it, dear friends. So here it is so. Of course, with the lemmatization, see here, this had have received its part of speech and towards the root word as have. And when in coming to the fisher, of course, it is a noun. So of course, it just comes only with the fisher, and where it's on to this am, is, and was. Now it just being to be the lemmatizing with be. So this is the exact first step of the text pre-processing. So which we just to say towards the analysis, data analysis. Yeah, this is the exact first step towards onto that. And let me just continue with the next one. Are you able to see my PPT here? Yeah, is it visible? Can I hear some yes?
Yes, ma'am.
Yes, ma'am.
Yeah, thank you. So here, yeah, when I'm just making this text to future, of course, this actually text to future, which we just say it is the process of future engineering towards the text data. See, actually, to analyze the pre-processed data, it is need to be converted into future. So depending upon the usage, the text future can be constructed using assorted techniques. So which I have already given like this as syntactical phrasing or entity phrasing, statistical futures, and towards the word embedding. So let me just see one by one towards that. And here it is what, as I have already specified, the first one comes to the syntactical phrasing. See here, dear friends. Syntactical phrasing involves the analysis of words in the sentence for grammars and their arrangement in a manner that shows the relationships among the words. Here I have just given you one of the example where which is just specified as like a dependency tree. And this dependency tree, which we just say, sentence are composed of some words sewed together, that is what. So the relationship among the word in a sentence is determined by the basic dependency grammar. So dependency grammar is a class of syntactic text analysis that deals with us like asynchronously binary relationship between two lexical items. Where lexical items it is between two words. So here I have just given one sentence. Bills on ports and immigrations were submitted by Senator Brownback, Republicans of Kansas. So here what it just means, something is submitted by someone. So of course, the submit is the root word of the sentence. And it's linked by two subtrees. One is subject and the object subtree. And each subtree is itself a dependence tree within relationship. So here, again, we are having bills, ports, and by proportions relationship is that. And here ports, immigrations, by conjunction relations is that. And this type of tree, when phrased recursively in a top-down manner, it just gives a grammar relationship or as output, which can be used as a future for many NLP problems, like entity-wise sentimental analysis or entity identification or text classification. So of course, there are so many things on that. And coming to this, so someone has submitted. Who submitted? Brownback is a submitter. And of course, there is so many functionality here also. Who is he? So he is a senator. And of course, he is also a Republican of Kansas. So this is how the grammar has been tagged towards the part of speech. And here, of course, it is an important attribute for text syntactics. Next comes the part of speech tagging. And apart from grammar relations, every word is a sentence is also associated with the part of speech like nouns, verbs, adjectives, adverbs, etc. is there. And the part of speech tag defines the usage and functions of the word in the sentence. And here I have just given you some of the main functionality, which is most important purpose here. One is word sense disambiguity. So on to the right side, I have just given you an example. So kindly just have a note of it. What's it? Please book my flight for Delhi. Second one, I am going to read this book in the flight. So what it just means, dear friends, so book is used with different context. However, the part of speech tag for both of the cases are different. In sentence one, the word book is used as verb, which in second one, it is used as noun. So this is how the word's sense would have. So the same word has different senses there. And next comes the one, improving word-based future. So a learning model could learn different context of a word when used, when that exact word used as a futures. And however, if a part of speech tag is linked with them, so the context is preserved. So that making strong future. And kindly have a note of it. The same sentence, if I'm just using here, book my flight, I will read the book. So here, when you tokenize it as like a pre-processing, when you tokenize it, the book comes twice. So other the words are only occurred only once, as like my flight is once, I is once only, and will occurred once only, read, and this all other than book occurred only once. But kindly just observe, dear friends. Yeah, not able to see the PPT?
No, ma'am.
Oh God.
Only Jupyter screen is visible there.
Oh, sorry. Are you okay now? Is it able to?
Yeah, ma'am.
Yeah, this is what I have just.
Syntactic. Yes.
This is what we have just seen onto the syntactic parsing. And there next comes the speech tagging here. And sorry for the inconvenience. I would have just asked you before. Fine. So here was the one which we just seen onto the word sense disambiguity. And next comes the one related to improving the word-based futures. And here it's what? So booking my flight, or I will read the book. So when I'm just making it towards the tokens, so here it gives the sense of the book occurred twice. But when I'm coming to the tokens with the POS, can you just observe with the POS part of speech tagging? So one book, it just gives us a verb, and the second book occurrence, it's on noun. So this is what improving the word that is based on to that of futures. And next comes towards the normalization and the lemmatization. Of course, this POS tags are the base of lemmatization process, which is just convert a word into its root word. That is what we have already seen in the example. And next comes the one efficient stop word removal. Dear friends, this stop word, the word stop word is actually which it just defines a low frequency or a less important word. That is what's said to be the stop words. When it just occurred in the sentence, of course, it has to be used in an efficient manner. So efficiently removal of that stop word would just gives you a good effective word of sentence. So in that manner, of course, we are here to remove the stop word. So of course, so let me just see it with an example in coming functionality. And next coming the one is entity extraction. So entity extraction here, so For the first example, I have just given that the machine would just understand only with the form of entity. So entity are defined as a most important chunks of a sentence. So it's like noun phrase or web phrases or both anything. So entity deduction algorithm are generally ensemble model of rule-based phrasing and dictionary lookup, POS tagging, and dependency phrasing. So the applicability of this entity deduction can be seen in automated chatbots, content analysis, and consumer insights. So there are so many things are there, dear friends. Of course, you can just come there with noun processor identification, where this exact step deals with extracting all the noun phrases from the text using dependency phrasing and POS tagging. And parser classification, this is classification step in which all the extracted nouns are classified into respective categories as like location or nouns or names or anything as like event. So of course you can just have so many phrase classification functionalities is there. And last one, it is entity disambiguation. Sometimes it is possible that entities are misclassified. Hence, creating a validated layer on top of the result is useful. For an example, if we just say as like Google knowledge graph, it is a one good popular knowledge graph is there. So which it just can exploit it for this purpose. So sometimes we just make some miscalculation. So it's very, very much a vast area there in named entity recognition. And of course, there are so many examples is there. You can use it in different fields or different, as you are all aware of it, natural language processing can be used in any type of applications, any type of field. Of course, even one among the example, we have just done a small classification of a chemical entity recognition, the named chemical, whether if you are just specifying it in a tweet, of course, you can just extract only the chemical words. And second example, how come I can just say, yeah, one among the one more application we have just done, that is from the tweet example, that is tweet extracted text, we have just featured only with pharmacy related text alone we have extracted. And we just done a small analysis related to pharmacovigilance. That is, if you are specifying any drug to be complaint, as for an example, this drug I am using for past 1 week, it is just giving a side effect like this, or if any tweet like that, that exact drug alone, it can be extracted. And what is the complaint? So we have just done it as like a pharmacovigilance, and of course you can just check my Google Scholar for that papers also. It is published in Elsevier. So and not only that, there are so many applications are there coming under this named entity recognition. And next comes the topic modeling. Actually, it is a process of automatically identifying the topic present in the text corpus. But actually, if we, for an example, if we just specify as a repeating pattern of co-occurring terms in a corpus, a good topic model results in us, like if we just say health, doctor, patient, hospital. So if we just give this alone as a keyword, and for a topic, what we just give? Yeah, of course, it is all related to healthcare. And if we just specify as like farm, crops, or wheat, of course, it is the topic related to a farming. So this is how we can just make use of the pattern of occurring towards the term in the corpus. Of course, it is also a very, very good applications. A number of applications are available. And that comes n-grams as a future. And see here, dear friends, this n-grams or which we just generally more informative as compared to this unigram. Unigram is in the sense the exact one single word as a future. And also this bigram, which we just say the occurrence of twice, are considered the most important features of all the others. And next comes the one, statistical futures. dear friends, this text data can also be quantified directly into numbers using several techniques or that. And here, one among the thing is term frequency, inverse document frequency. So, which is exactly a weighted model commonly used for information retrieval problem. And this term frequency, where the TF for a term T is defined as the count of term T in the document D. And this inverse document frequency, that IDF is for a term is defined as a logarithmic of ratio of total documents available in the corpus and number of documents containing in the term T. And next comes the one count density readability. So as I have already said, this we need when we just use of this text, we need something that's like a count, and which we use to make it in models and do analyzation. So this exact future might seem trivial, but shows a great impact in learning models. So some of the futures like this word count or sentence count, punctuation count, or industry specified word count. So there are so many things out there, as you can just get it as like a readability measure, such as syllable counts is there, small index, flexi reading case. So there are so many things are there available towards the model, which we just create a vocabulary dictionary and assign an index to each word. So this is also one among the very much used functionality. And next, that comes the word embedding. Dear friends, this word embedding is the modern way of representing words as vectors. So the way the word embedding is to redefine the high dimensionality word futures into low dimensionality frequency vector. So by preserving the contextual similarity in the corpus. They are widely used in the deep learning model, mainly on convolutional neural network model and recurrent neural networks also. And of course, we have two popular models as like word2vec and globe. So these are the two models to create word embedded of a text. And this word2vec model is composed of pre-processing model and a shallow neural network model called continuous bag of words, and another as like skipgram. So these are all widely used for so many NLP platforms are there. Okay, so for now, let me just see one full flow of natural language processing so that I think you would just get a good impact onto the understanding related to this. Yeah, are you able to see my Jupyter notebook of getting started with natural language processing? Yes, yeah, thank you, dear friends. So here I have just need to give you a small impact related to the flow of it. And of course, dear friends, here what I have just given this, so this is the exact flow of every context. So first of all, we have to include the necessary libraries, then we have to include the data, and we have to do some EDA process. And here the exact process is on text document and creating onto the future. Here we are going to transform the tokens towards the vector. Lastly, we are going to apply some classification model. So this exact model is based on a text classification. So kindly just observe for a while. So here I have just given you small content related to necessary libraries. So yeah, of course, the first two is all about the data related. So NumPy and Panda has been included. And next, the one related to the text processing libraries. Yeah, one among them is regular expression, the string, NLP tool, and next it's for stop word removal. And next, we are going to apply it onto a model. So here it is for the model selection and future extraction. Of course, the future extraction, it is for counting the statistical count we need. So for that, count vectorizer and TF-ID vectorizer has been included. And for this one, this two line, that is logistic regression and multinomial, it is for classifier. So let me just apply it for this two model algorithm. And of course, to evaluate the metrics, we need F1 score. For decomposition, so for pre-processing, we need decomposition, model selection. Of course, I have already included model selection. Fine. And yeah, with grid search CV and straightforward curve things and randomized research CV, we have included all these under sklearn. And next, for plotting purpose, we have included visualized library of Python, the matplotlib and seaborn. And next to the last, for avoiding the warnings and towards the system, we have included it. So here we go for the execution. Yeah, it's done. And then next comes the one, dear friends. Here we are, of course, whenever we just use the data, yeah, we have to, on applying to a model, we have to split it towards the training data and testing data. And of course, it is advisable to have a training data of 70 to 80%. And testing data, of course, 20 to 30%. That is what the usual task of inclusion. And when coming to this, dear friends, here we have already a separated training data and testing data. So I have to include both the things. So here it is what the training data, and here it is what the testing data. So before going on to this, yeah, of course, let I just give you a small intro of this data. It is the one which it has a set of tweets belonging to whether it is a disaster or not. So we want to classify whether exact is or how long it is a classification of disaster and not a disaster. So that is what we are just going to do here. And coming to the one, so let I have a look of the things. So observe, dear friends, in the training data, we have ID, keyword, location, text, and target. Of course, we have 7,613 records with 5 columns. There we go with the testing data. Yeah, here we have 3,263 records with 4 columns. Are you able to observe anything odd in here? Yeah. Can you observe anything related to this training data and testing data? Let I just see who can. Yeah, of course, of course. So see here in training data, there is a target column, but in testing data, there is no target column. Yeah, of course. We are just going to classify according to that. So coming to the analysis, we have to check for, so whatever we are just doing, of course, we have to check, yeah, exactly, Srinivasa. So it is one column is reduced here. Yeah, so when I'm just making towards the analysis, of course, we have to apply it on to the both the data where we have already had a splitting data here. So training data and testing data, we have to check over. So first of all, let me check for missing values. So here on checking the missing values, oh, lots of missing there in the keyword and to the locations. So as you have just to see, dear friends, so when on just making this functionality, so each and every records here, of course, in training data, we have 7,613 records. Almost in that, 2,533 are missing. So let me just check for testing. Of course, here too, the keyword and the locations here also missing is there. So lots of values are missing in the location and the keyword, of course, in both the training and testing data. Okay, so let me just explore furthermore on to the each and every columns. So first of all, let me just take the target column. Of course, the target is the one which we are just going to classify it. Okay, so here in this target column, of course, it is there only in the training data, not in the testing data. So let me have the count towards the training data. So how many disaster and non-disaster is that? So see here, yeah. Of course, here the one it specified as like disaster and 0, it is not a disaster. So see here, dear friends, we are having 3,271 disaster tweets and 4,342 non-disaster tweets. So if we want to check with the plotting, yeah, here we have used Seaborn, and of course it is a bar plot. And with the index value of the training data with the target column. So here I just show you the plotting. So see here, of course, this is what. Okay, then now comes here. Of course, here kindly just given a key that the disaster looks like, that is, we are having the almost it is not a far difference, but anyhow, when coming to the 7,600 plus records, we are having, of course, balanced data only. Okay, next, going to the one for making it towards the valuation. So I'm just going to take it, the one as the disaster tweet and 0 as the non-disaster tweet. So here I'm just separating as like a frame, and I'm just going to include it, assign it as like a separate variable. So here, kindly just to see here. So I'm just going to use this disaster tweet and non-disaster tweet variable, and for one more possibility. So for I'm just giving it. So yeah, when I'm just seeing the first index value of it. So forest fire near Lawrence, Canada. It is the first data in disaster tweet. And let me just observe the non-disaster too. Okay, I love fruit. So this is the one among the non-disaster tweet. Okay, now moving on to the second column. It is all about keyword. And see here, dear friends, this keyword column, what it just gives you, it is all just specifying how you are making use of it. So of course, it is a tweet data. So we are just going to make use of how the exact tweet data has been made use of the keyword. And here, let me just take the topmost 20 keywords from the training data. So here we go. Yeah, this is what. So whether it is a disaster related or non-disaster related. So here we just have the topmost 20 keywords among the training data. And here we go, where only the disaster and non-disaster, it is just specified like it. Okay, next there comes the location column, and of course we have a numerous of missing data, but anyhow, how to standardize it? So here what I'm just going to do, even though if it is anything as like United States, yeah, I just want to replace it as USA. If it is New York, yeah, let it be as a USA. So I'm just going to make it as a common standard name for some listed one. So here, of course, I'm just going to take only for an example. So here I just made as a location with some standard names, and once on making it towards it, I just want to know the topmost five location which have been tweeted. So which I just have it in my data. So kindly just have a note of it. So of course here, so USA is the one highly tweeted, and there comes the next as UK, and towards the Africa, India, and the next one which we didn't make a replacement, it is as like old word. Okay, so that is what it has been given here. And then next comes to the main process. It is all about text data pre-processing, which we have discussed now. I just want to give you a small recap here. So of course, when you just want to clean the data, yeah, of course, kindly just change into any one of the case, lowercase or uppercase. And here we are just going to make it as a lowercase. And next we are just going to make it towards the removing the noise. And that going for tokenizing, and next for the stop word removal. So this is what we are just going to see it. And then next comes the one stemming and elementizing. So let me just, first of all, let me take the first top 5 text from the training data. So kindly just have a look of it. So our deeds or reason of this earthquake. Okay, for your information, now I just let you know. First of all, what we are going to do, we are going to make it for lowercase. So just have a note of it. We are to make it for lowercase first one. And next one, we have to remove the noise as like the unwanted as like the meaningless, the is or this like that. And we have to tokenize it as like separate text. And next we have to remove the stop words, which is very low effective. Okay, so going for the stemming and lemmatizing, and of course, for your information, we are not going to use stemming and lemmatization for this current applications. Okay, so let I just go one by one, step by step. So kindly have a note of it, dear friends. So this is what the first step to clean the text. And kindly see here, dear friends. However, when we just go towards the needed or not needed necessary steps, finally go on to the object of the project. Why we are, where we are, for what the purpose we are using here. And mainly the usage is on to the problem at hand. So here, we are not in the purpose of routing towards the word. So we are not going to apply the stemming and lemmatizing. So let me just clean the data. So as I have already specified, for cleaning the data, what we just done, of course, we have lowered it. So the case, we are converted it into lowercase. Next one, we have removed the, kindly I just to show you the code here. So we have just removed the square bracket, we have removed the links, we have removed the punctuation and some numbers, even though if it is containing some numbers, we have just removed it. So that is what here it is included in this function. And once for all, yeah, kindly have a look how this exact text has been. And next, there we are with a small graphical output in a word. So which we just say as a word cloud. And here I have called the exact disaster tweet and non-disaster tweet. So we are just going to have two subplots. One is for disaster tweets and second is for non-disaster tweet. So we are just going to have the word cloud 1 and word cloud 2 with the title of disaster and non-disaster tweet. So kindly have a note of it. So for this, we have to include the module word cloud. And here we go with the disaster and non-disaster tweets. Fine. So next, let me just move on to the tokenization. So before going on to our particular token example, I am just giving you what is tokenizing. Yeah. According to the tokenization, we are going to split the exact text in a in a sentence into a single text. So here, are you coming here or not you? So here, this is the exact text when on just giving towards the tokenizer. And here I have just given you 4 different types of tokenizing as like white space tokenizer, tree bank word tokenizer, word punctuation tokenizer, and regular expression tokenizer. And yeah, on inclusion of this exact module, yeah, we are just going to get it the output towards the tokenizer 1, 2, 3, and 4 respectively. And kindly observe the output here. So see here, dear friends. For this white space, wherever the space is there, of course, wherever the white space is there, it's just done as like it. For tree bank, yeah, kindly observe. Of course, the comma has been separated and this are not. So it is furthermore separated according to its tree functionality. Tree functionality, whether is you are having any further classifications. And coming to the punctuation, and of course, here the apostrophe, the sub comma are all separated separately. And the regular expression, of course, only the text we are going to have it, not any other symbols or not any other apostrophes or commas like that. So only the text is the main process here. So we are going to make use of the regular expression and towards our training and testing data applied here. So observe it, dear friends. So the regular expression tokenizer is being used on the training data and the testing data of the text column. So when on just seeing, so each and every word now has been tokenized. Okay. Now next, going on to the one stop word removal. So of course, stop word is the one which we just say the less efficient or low efficient values, or very frequent, which is not much more frequent. So that is the exact word we are just going to stop it. So of course, here I have just created a function for making use of the removal of the stop word. And we are applying it onto the training data and the testing data. Of course, yeah, kindly have a note of it, dear friends. If you want to just make use of this stop word functionality, yeah, you have to download it, this one. So of course, as I'm having already, it is downloaded and we are having the functionality. So this one, yeah, it just takes a few minutes before on to employing it. So kindly have a note of it. It is just being applied onto the training data and the testing data. And next, it just moves on to the token normalization. And this token normalization, of course, what it just means is for stemming and lemmatization. So we have already discussed about what is stemming and lemmatizing. So anyhow, let I just give you a small info. So see here, this is speech, cats, wolves, tongue. So this is the exact text. So when we just want to make it towards this exact text onto the stemming, and if we need to have the root word, and of course we are going to have the tree bank word tokenizer here, and yeah, let me apply it on for the stemming and lemmatizing according to its function stem and lemmatizing. So one's on applying. So see here, stemming the sentence here we just get with the cat, it is stemming the plural and it just gives cat. And to the same, yeah, wolves has been given as a wolf, and the togged, the word has been trimmed here and given as a duck. But when I'm giving for the lemmatizing, kindly just observe the root word, dear friends. The feet cat has been converted to foot and cat. And of course, the wolves has been as like wolf. Yeah, this is all the exact functionality for normalizing. And of course, we are not going to apply it towards it. Yeah, fine. Let me just combine everything towards the functionality onto our training data and testing data. And it is important note here, dear friends, that is stemming and lemmatization sometimes do not necessarily improve results as at times. So we don't want to have it in our functionality. So, but rather preserve their original forms, because their usage actually differs from application differ to application, or a problem to problem. Okay. So for this problem, I didn't use it. And let me just continue towards the processing, pre-processing again. So getting it all together, here it is gone. And next comes the one transforming towards vectors. And of course, here in this application, there is no count vector. That is one word. It is not repeated, or there is no occurrence towards one word towards the other tweet. So here we didn't have the count vectorization. Of course, let me just check for TF-IDF. Yeah, here too we didn't get anything. Yeah, applying on to this on the classifier. Dear friends, actually you can just use any type of classifier. Okay. Here I have just specified as like a logistic regression and the Navis-Bay classifier. Of course, you can just apply anything of the classifier. And when I'm just applying towards it, so I'm just using for two the thing. One is for the particular classifier, and second one with the TF-ID functionality. So okay. So this gives you an changeover of the accuracy. Of course, let I just check for the logistic. Yeah, see here, when coming to the scoring of F1 scoring, and here I just get 68%, and with the TF-IDF, I am just getting 64.7. And when coming towards the Navis classifier, so here I'm just getting 8. for 72% in normal multinomial, and were 73 in, of course, in TF-IDF. So this is up to the exact functionality where you use it and where you, and here just to give you the functionality difference, you can just apply it in any function or any application, and you can just make use of the according to this classifier, you can just have a comparison or improvisation. It is up to your application based, and based on to the what we can just say. Yeah, it is exactly the problem statement. Okay, yeah, coming to the end difference here, let me just give you a small intro related to what are all the current recent trends there in this natural language processing. Of course, sentimental analysis. So natural language processing is an integral part of everyday life and becoming more as language today is applied to diverse fields like, for instance, customer service chatbot is there, interpreting and summarizing electronic healthcare records is there. There are so many things are there, dear friends. So when coming to this sentimental analysis, exactly, it is the process of classifying the emotional intent of the text. So generally, the input to a sentiment classification model is a piece of text, and the output is the probability that the sentiment expressed is positive or negative or neutral. And there we go here, named entity recognitions is there. So where this exactly aim to extract entities in a piece of text into predefined categories, such as personal names or organization or location and quantities like that. You can just go ahead. And information retrieval, we just find the documents that are more relevant to a query. So this is a problem every search and recommendation system faces. So the goal is not to answer a particular query, but to retrieve from a collection of documents that may be numbered in the millions. So a set that is most relevant to the query. So that is what here comes the information retrieval. And there next comes this one, the text classification. Of course, we have done the text classification flow, but this one is inclusion of neural network. So when coming to neural network, of course, it is the one exactly different from the normal neural network because it operates over a volume of input. And here, each layer tries to find a pattern or useful information of a data. So convolution is a process through which futures are obtained. And the convolution operation is responsible for detecting the most important futures. So the output of the convolution process is going towards the future map, and the future map is computed through the application of future detector to the input data. So, and here in some deep learning framework, the future detector is also referred to as a kernel. And yeah, of course, the kernel can be of 3 by 3 matrix. And you are free to choose any filter that works well for your, of course, to your problem. And here, pre-trained word embedding can help in increasing the accuracy of text classification. Of course, next coming to the RNN. So recurrent neural network. So many techniques for text classification that use deep learning process which words in close proximity using n-grams or window which we just said that CNN. And however, they can't capture the exact content provided by a particular text sequence. They don't learn the sequence structure of that data, or whatever word is dependent toward the previous word or in the previous word sentence, it is not able to remember. So that this RNN remembers previous information using hidden states and connect it to the current task. So this one is very, very useful and also being used to generate mathematical proofs and translate human thoughts into the words. So it is very, very much used nowadays, of course. There next, it's very interesting auto encoder. And autoencoder or deep learning encoder and decoder accord the proximity of mapping from X to X, that is input towards the output. So they first compare the input future into the lower dimensional representation, which we just say as like a latent code, latent vector or latent representation, and learn to reconstruct to that input. Okay, so the representation vectors can be used as input to a separate model. So this technique can be used for a dimensional reductionality. Okay, and next comes the one sequence to sequence, which we just say encoder decode sequence to sequence. So this is an adaptive adaptation of autoencoder specialized form. Mainly used for translation or summarization towards similar task. Okay, and next one, it is all about transformer. See, actually, dear friends, the transformer, it is what which we just say a self-attestation mechanism has been done here. It has an architecture that has revolutionized NLP in recent years, and leading models including like Bloom or Jurassic X and turning energy. So it has also been successfully applied to variety of different vision tasks also there, including making 3D images from the text. So this transformer is just going to evolve like huge things in coming recent years. Okay. And of course, this is what the blind pipeline, which we just say. So whatever we just give it as like an input. So kindly have this as your pre-processing functionality, as making it into lowercase, removing the HTML tag, and making it tokenizing, stemming, lemmatizing, all these towards the input, and understanding onto the data. So this is what the main important for what you are doing, for why you are making use of it. So this is the main thing. And towards coming to this, dear friend, what is the purpose of the flow? What is the purpose is in the sense where this exact application you are just going to mainly use it in for. Okay, so that is the main thing here. It is as like whether on named entity or engram identification or for topic modeling or sentimental analysis or information. So what is the exact purpose you are doing? So this is the exact pipeline where the exact whole NLP has been given in a single flow. And next coming towards the friend. So here it is the one most used libraries. So whenever we just talk about the libraries, so NLTK, it is the one library that is written for Python. And next comes the popular deep learning libraries as like TensorFlow or Python, which we just make use of it. And Hugging Face offers an open source implementation, and of course waits for over 135 state-of-art models. So the repository enables easy customization and training of the models. And GenSim, it is mainly for topic modeling and human-related modeling is there. And TextBlob, actually it is easy to for APIs. And the standard 4-core NLP, it is a whole package of these things is that. So of course, we are having a huge list of libraries for mainly for NLTK. So there is a natural language processing. And apart from this, these are the main research that are recently there related to this deep learning and combining towards the NLP. So that is advancement in transformer-based models, multimodal learning, or explainable model. Actually, here the when the model becomes more complex, of course, it becomes more difficult to understand how they make their decisions. So that explainable AI is very much used. And nowadays, of course, we are in the era of this chatbots or visual assistants. All this comes under conversational AI. And next comes the transfer learning. Of course, here, the one which we just say, the pre-training large language model up like ChatGPT which is exactly a game changer now. Okay, but still more to be explored, termed as like having a competence with Google also. And next coming the ethical consideration. As with any powerful technology, there are an ethical consideration to be addressed. So when it comes to deep learning and NLP, further research could focus on developing models that are more fair, transparent, and accountable to the public. So yeah, coming to the conclusion, dear friends, is NLP is one of the fast growing research domain. And with application that involves like translation, summarization, or text generation, and sentimental analysis. So everywhere we are using this natural language processing, and it is an exciting and rewarding discipline. So and has potential to profound impact the world in many positive ways. Unfortunately, NLP is also a focus of several controversies. Is there understanding them is also part of being a responsible practitioner. Okay, so for instance, researchers have found that model with more things towards bias found it in training the data. So whether they are counterfactual or any other thing, and of course, we are having a huge things related to this NLP. And of course, we are mainly based on to that natural language processing, and there are so many things that can be done towards the psychological or done towards the text or tweets or in social media. Huge applications are there is the thing, dear friends. So yeah, for any research related to natural language processing or image processing or pattern matching, you can just kindly ping me on to this LinkedIn. And here I have just given my link of my channel. And of course, here you can just contact me, of course, here. And yeah, really, yeah, I'm having some questions, I think so. Yeah, how does NLP will influence its powers? Yeah, we have already specified, dear friend, in the ChatGPT, of course, when we just make it towards a game changer now in recent current 3 months, there is still much explored in the term of transfer learning. So how can we use pre-training to improve models in other domains? Even from extracting from the text, yeah, you can just make it over towards the other functionality, other field, as I have already specified. You can apply this NLP in any field. So yeah, of course, you can just have your word. Yeah. Any more questions is there? Yeah, if you are having any questions, yeah, you can just have it. And of course, I just shared this Jupyter to the accuracy level of logistic regression and which one is best. Of course, here what we have just seen is, yeah, I just share you, dear friends. So what we have just given here, yeah, kindly just have a note of it. The Navis Bay classifier, it just gives 72%. When I'm just coming towards logistic regression, it is only with 68. So that is without TF idea. So of course, here Navis Bay gives the best one. I think so. Yeah. Fine. So happy for that. Yeah. Any more questions, dear friends?
Ma'am, there was one question we noted. However, the answer had come just in the next slides, but still I'll read it. What is the difference between lemmatization and stemming in NLP? So your slides had explained it. So if you can still put up a brief answer to this question, the difference they're asking.
Yeah, see, actually stemming, it is exactly the trimming of the prefix. So it just gives only the root word. But lemmatization, it is inclusion of course, it is an inclusion of part of speech tagging with a grammatical, whether it is a noun or verb or adjective or adverb. So that inclusion, of that, It just makes you much more efficient working, which is a future extractor function. So it is advanced one rather than stemming. So of course, this both are things fairly for what purpose you are using and to where it is very used. So mainly used according to the meaningful sense. So if you need for the particular trimming and further if you want to extract something, yeah, kindly make use of stemming and lemmatization. Of course, we didn't do here. Yeah. Any more questions? Is that reference?
There is one from Chavi Sharma.
Yeah, please.
How does statistics play the role here, as we have moreover a lot of things implemented through toolboxes and libraries?
Yeah, actually, see, whenever we just say machine learning, it is one among the statistical model of the functionalities only. So what we just take it from the statistical, yeah, we are applying here, it is as like an algorithm. And whenever we just take this as text processing, sometimes we need something as like a numerical. So that numerical in that way, yeah, it is done by statistical features. So it would be very, very much useful. So when we just make use of the statistical under this text processing.
Yeah, man. If participants have more questions, we just have the Q&A open here. And we also wish to inform that we have just posted 1 minute before the attendance and feedback link, which has been posted to everyone. So I hope you are able to see that. Sujay, hope you can see that also. We have posted it to everyone. Participants, please note that attendance is being taken for every session. So the feedback and attendance both are being taken. Dr. Ajanta has been kind enough to share her contact details and LinkedIn profile. The link has also been posted, which will be helpful for everyone to see and get in touch for any queries as well. So we are still waiting for more questions if there are any. Yes, Rohiji will be sharing the feedback link. Don't worry. For all the participants who are joining the sessions, you stay with us, keep interacting, and let's keep that happy question of attendance away. The reason is if you are present, you are very much here with us. So we'll ensure that nothing happens to your certification and everything. Dr. Ajanta, if we are just waiting for more questions, if there are any.
Yeah, please.
Yes, ma'am. So all the participants can, if you have any question related to the presentation given by ma'am, or if there is any apprehension that you have, if there is any possibility that you see that we can work on, you can please share. Yes, we are just looking at the chat. If there is no question that we have missed. Almost every question has been answered.
Yeah.
Yes, we'll just give just last 1 minute to all the participants. If you have a question, she's still here with us for the next, I would say 11-12 minutes are still marked for you.
Yeah, fine.
But the
No
presentation has been so extensive that because the subject area with which I'm associated is language.
Yeah.
And the area all of the participants will be associated with will be like that way, AI or ML or this. But the way you brought that parts of speech or language or that accuracy or the text to speech and how the things are working in the back end, I mean, that's quite complicated, I would say, complex, but
yeah,
very
of course,
rich.
Yeah, of course, actually, when we just speak about this natural language processing, of course, when towards this grammar or towards this corpus, yeah, it would be vague like that. But when we just explore one by one, of course, you see, actually, when we just speak it, yeah, it can be taken into their native languages. It can be taken into different corpus and different language translations. So huge applications are there in this. Huge applications are there in natural language processing, and of course, the next 10 years, of course, it is just ruled by natural language processing. Because actually, even this Tesla, which we just say, yeah, of course, it is just taking the speech intake and it just making it as like and commenting. So it is that recognizing the speech and it's just making use of it. Yeah, ma'am, my topic is translation. Yeah, Pragya, please. Can I get the data set of Hindi poetry to English? Of course, there is Hindi to English translation data is available. Yeah, you can just kindly ping me or you can just mail me so that you can just get it done.
Thank you, ma'am. Participants, we have already received more than 160 attendance or the feedback entries also. Yeah, we do have people putting up chat, GPT and NLP in the
Yeah,
parallel
even
thing.
chat GPT is the best way to start NLP, I guess. Yeah, of course, we can actually see when we just speak on to chat GPT, yeah, of course, there is really a big debate. We can just make it whether with chat GPT or Google AI.
So,
yeah.
if we still ask you one, I would say not a debatable question, but still it is. Like
Yeah.
Turnitin will say that we are bringing up system to check out whether people are using chat GPT or something. What do you see? Like, should we accept it or should we stand in protest as people protested against the calculators, like against this
See,
thing?
actually, yeah. See, whenever we just it is the one which we just say as the people's laziness. It just evaluated, so many tools are there. Okay, so of course, if we are dependent onto this machine, of course, we are depending onto this ChatGPT and Google AI. So even though, see, whenever we need to have something, rather if we know we are able to identify something, but still we are depending onto this Google search. So let it just do, let the machine do for us. So that is what we are expecting. Of course, people like that would always depend on to the machines and machine related innovations only. Of course.
Thank you, ma'am.
Yeah.
Quite an interesting thing, I would say. From the technical, we can keep on talking and debating as well.
Wait.
So,
yeah.
Yeah, and everything will make it rich that way.
Yeah, here one more. Yeah, see, actually, when we, yeah, of course, when we just compare towards this ChatGPT or Google AI, which one is better? Yeah, here, which one? Of course, yeah, it is not exactly towards the functionality, but to be true, I just been pleased with Google because why? Because actually, yeah, of course, when coming to the conversational AI field. The first point when rather choosing this ChatGPT, if we just go for Google, but yeah, it has an extensive data. Second, yeah, it has been more techniques related to machine learning. And coming to the natural language processing, yeah, it has more capability than ChatGPT. And integrations also with that, with other Google search services also there. And last but not least, cloud infrastructure. Of course, Google has a robust cloud infrastructure that can support the development and deployment of conversational AI systems. So the cloud service provide developers with access to powerful machine learning tools and resources that can be used to build and deploy conversational agents. So yeah, when coming to this debate, of course, I just go with Google rather than ChatGPT.
Fine, ma'am. Like we may not be able to fight with technology, so better to be friend with it then.
Yeah.
Thank you very much.
Thank you.
How we won't call it the end that way. It's the beginning. It's the beginning of a new invite to you that we'll keep on getting more people to participate in such workshops with us. So is there any question coming to anyone's mind, or we'll be concluding the session with some important information, and then we'll be starting with the next session very soon, just after 7 minutes.
Yeah, thank you, Seema. Thank you for the opportunity. And I'm just like, yeah.
Anytime, ma'am. Thank you so much for your talk.
Yeah. really happy to be there and sharing this in this forum. So really happy for that. And yeah, of course, all related to my knowledge.
Yes.
So really happy to have a huge set of participants there. Of course, we had a good interactions also. So
Always your sessions
yeah.
Outstanding.
Yeah, thank you. Thank you, Praveen sir. Thank you, Seema. Thank you. Bye.
Okay, bye, ma'am. Thank you.
Yeah.
Thank you. So participants, we shall be initiating the next session in precisely 6 minutes after now. So that is 4 p.m. Tashkent time. So we have these minutes for any query, any problem that you faced with attendance, because we have decided to close the attendance in the next few minutes. And then we believe all of you have marked attendance. Please note that the attendance is mandatory for every session. There'll be 8 sessions and your certificates will be based on your attendance only. So be present and be participative as well. Give us these 5 minutes to come back. Our next speaker has already joined in, so we'll be initiating the session very soon. Thank you very much for being with us, and we expect the same enthusiastic participation in the next 1.5 hours as well. The session timings have been kept from 2 to 4 and 4 to 5:30. However, on few days, we have kept one extensive session that you can see in the schedule sent to you. If there is any problem, the email ID, please prefer the email ID. Just drop us an email and we shall be writing back with the solution and all possible resolutions. So thank you very much. The feedback link we are just putting up again. And please, yes, the feedback link has been posted as a Google form link. So kindly in the next 5 minutes, finish it so that we can open our session with Dr. Jyoti Prakash Singh, who is joining us from NIT Patna, India. And we'll be back in 3 minutes precisely with Dr. Jyoti Prakash Singh starting his session, and we shall introduce the topic as well. Thank you, everyone. Just 2 or 3 minutes more, and we'll be back. Yes, so everyone, we'll be initiating the session 2 of day 1. And as we are moving ahead, we have our second speaker of day 1 with us, Dr. Jyoti Prakash Singh, who is a professor at National Institute of Technology, Patna, Bihar in India. And sir, we have the privilege to welcome you, and we shall be initiating this session with a brief introduction of yours. And this will give us a moment of pride as well at Amity University in Tashkent. So all the participants, please note a few things before we initiate the session. The attendance and feedback link will not be posted on request or something. We'll be putting it at the conclusion of the session when we initiate the Q&A, or before that at a random moment. One. Second, we shall be very happy to receive your Q&A in the Q&A session, and we shall be presenting all questions to Professor Jyoti Prakash Singh at the end of the session, the conclusion one. Thank you very much for being with us, and we are initiating the topic. Professor Jyoti Prakash Singh will be speaking on his deep learning generative adversarial networks. Now, when we talk about it, before that, we shall be introducing Professor. Dr. JP Singh possesses strong command over artificial neural network computer communication, computing in mathematics, natural sciences, engineering, and medicine. His skills and expertise include artificial neural networks, time series, text analytics, natural language processing, and social media analytics. He is also an expert on text mining, machine learning, and deep learning. He is a member of the IEEE Computer Society USA, Computer Society of India, International Association of Engineers Hong Kong, and International Association of Computer and Information Technology Singapore. Just to cut short his introduction, though we know that he is an achieved person, accomplished researcher as well, he has got more than 200 publications to his credit, all in reputed journals and publication houses. Sir, we welcome you on behalf of Amity University Fraternity, Amity University in Tashkent, and request you to kindly deliver your session and bless us with the knowledge. Professor Dr. Jyoti Prakash Singh. Sir.
Thank you, sir. Thank you for your nice introduction. And really, it's a great pleasure to be with you and sharing whatever I can share within this half an hour. And obviously, it will bring a relationship with you and all the participants, those who are listening. So if I can help them now as well as in future, that will be my privilege. That will be my achievements for this particular session. So thank you. And now I'm going to start sharing my screen. I hope my screen is visible to all of you.
Yes, sir.
Okay, so thank you. Already, sir has told about myself. So this is what I'm going to discuss today. And I'm skipping this one. Exactly. So my topic or the talk today is exactly what is deep learning, and then moving on to the generative adversarial network. And I think that is in sync with the title of this workshop, FDP, whatever you say, which says that it's basically advancement, smart future technologies in ML and AI and ML. So let us start answering this question. What is deep learning, and why is it generally better than other methods on image, speech, and certain other type of data, especially speech and protein data also we can see a lot of this nowadays. So people are using this sort of technology. Coming to that answer, so let us start about the learning. So if we want to learn, exactly how we learn. So consider ourselves to be a kid. So whenever I normally start learning, or I start thinking of this machines, how to make these machines intelligent, I consider myself to be basically a young guy of say 6-7 years old. So a 6-7-year-old kid, basically, how he or she may learn. So given certain images of say motorcycle or say some sort of bike or car to a kid, how the kid will make a mental image of that. So normally a kid will make a mental image that, okay, this image has got something, say 2 set of tires and or wheels, and then there is a handle, there is a seat, and so on. So the kid will make a mental image consisting of these abstract notations. But the same thing when we give it to the computers. So we give computers like this. So we give a matrix, we give certain numbers, we throw certain numbers to the computers. So computers normally see a matrix consisting of, if we consider it to be 8-bit image, then consisting of some number between 0 and say 255. So this is just a small portion of this whole bike shown enlarged here in the form of a matrix. And this is how the whole bike will look to the computer. Now, it was very easier for that kid or a human being to recognize or identify this sort of object because we have learned, or when we see the picture, we really see the concepts of that particular images or that particular picture. But when computer sees it, it sees certain numbers. Now, how to make some meaning out of that number, and that's where deep learning is playing a big role. Say, if we just if we give a matrix to the computer, say a matrix or basically images consisting of the matrix to a system or to anyone, say images of say some trees and then bike and then some sea fish and then a car. And so if this is given to a computer, this will consist of the matrix. And if we plot them, if we try to represent them, so this will be something a pixel 1 versus pixel 2, and they may be distributed like this. So a car image may come here, a bike image may come here, a fish may come here, a tree may come here. We know that these two will be of one class. It's a non-living thing, a living thing. So these two are non-living things, they should go to one class. But it is really difficult to differentiate or group them from this image. So this is how a raw image representation, that is in the form of matrix, will look like. But consider if we really extract certain features from those images. So given those images, if we start extracting features, so if we have some magic wand, and if we just given those magic wands, we extract that, okay, given this image, I can extract that there is a wheel, there are wheels, and then there is a handle, then there is a seat, and so then probably we can represent this image in terms of certain axes which consist of some wheel versus handles. And then if we plot them, we'll find that all sort of motor vehicles like car, bike, and all sorts of scooters, everything may come here. Whereas the others, living things may come on this side because they will have wheels, they do not have handles, and so on. So they will be totally easily isolated or easily distinguished from this non-living things. Now the question is exactly how to get this feature. So exactly before the invent of machine deep learning, what people used to do is, given certain images, we used to extract features by our own. So we used to write simple programs, simple operators, and some simple codes, or say some methodologies, some mathematical operators, which used to give us certain features. So we used to call them as feature extractions. So given a car, we used to extract say 10, 15, might be sometimes 100, might be sometimes 200 features. And those features were then given to the classification algorithm, and the classification algorithm like net Bayes algorithm or support vector machine or say k-nearest neighbor might be a decision tree or more advanced ensemble techniques like random forest or some sort of gradient boosting and so on. So they used to classify this features. Basically, the classification used to occur based on these features, and then they finally used to give certain output, what was requested or what was expected from that particular model. Deep learning, in fact, integrated these two. So both this machine learning as well as say basically this feature extraction as well as this classification part is integrated into one component. So now you see that this human intervention is now reduced. And now we have a model, and this model itself will extract the features. So given this raw image to the system, this model will extract features what a human used to do. Obviously, this feature will not have the similar, say you can say nomenclatures or similar say meanings associated with what a human used to do, because when human used to extract those features, they used to give them a names like wheels, might be some sort of handles, some sort of wind glasses, seats, and so on. But this deep learning models will also extract features in a similar nature, but the meanings or the names associated will not be there. They will be something abstract. We call this as concept. Like I joined in the first session and I saw man was explaining about, I think, the word embedding and so on. So on text data. So consider a text data. As I told, I really mostly work in text data. So that's why I was very interested in that one. So in text data, so if you see a text data, like we can extract the number of nouns, pronouns, number of adverbs. So this sort of features also we can extract. And then there comes the other embedding techniques, like we say that, okay, kings and queens, they should form one group, or all the names of the cities should be say residing together. So we create, basically we have already told that we create a vector. Now, how those vectors, what are those vectors? Those vectors are basically these features, what human earlier used to do. But obviously the names, what human used to do is not there, but they are the features. So this is what a deep learning model does. So a deep learning model integrates this feature extraction as well as the other models, ML models like classification or clustering models, whatever you are doing. So if you see or if you visualize or you think of, probably this part will give you some sort of feature extraction algorithm. So if we go layer wise, so first layer may, in case of an image, may extract some say curved lines or straight lines or different sort of lines at different angles. Then if we go deeper, so those curves may form semicircular or different sizes. And then if we go more deeper, probably we can get more circular structure. And then if we think of human face, if we go deeper and deeper, probably we can create the notion of say eye, nose, mouth, lips, and so on. So that's how this deep learning model basically goes. So now, so if we say what is a deep learning, this is the question we started with. So deep learning basically is a neural network with several layers of nodes between input and output. So we do not have just one or two layers. In fact, we have more layer of nodes, and that's why it is deep. Why is it better than other methods? Because the series of layers between the input and output do this feature identification and processing in a series of stages, and just as our human brain does. So this idea, like what our human brain also does, so it goes in a series layer by layer, and every layer it is extracting some sort of feature, and we are say binding or basically refining those features till we reach to the last layer before that classification or the ML technique. We have a concrete feature. Why is it good? Because it requires less human effort, as we can see from this figure. So we have eliminated this one. That means obviously the human effort is very much, we have diminished it, reduced it. Modern data sets are enormous. So even with limited amount of data sets, we can do the training. And this is what I also told, that concept learning. So we are trying to learn the concepts. And then learning from unlabeled data. This is what we'll see in the later part of this lecture. So feature engineering, there are a lot of say expert opinion about feature engineering, what a feature is and why it is really difficult, why we should move to deep learning. So coming up with feature is difficult, time consuming and requires expert knowledge. That's an expert, say Andrew Ng has told this one. When working on a machine learning problem, feature engineering is manually designing what the input X should be. And Sam Neill has told this. Now, what exactly is new in deep learning? So we used to have a network like this. Now we have a network like this. So this is what we call as a simple neural network, which is a classical neural network. And this is basically some sort of deep neural network. So what's new? The idea is same. So what used to be earlier, the idea is same. So the basic idea of a neural network, if we see, all of us, almost those who are attending or might be knowing, it's my presumption. Still, I will just give a minute to this, that we are giving so this input and then multiplied by this weight. Then there is a summation and then we extract it through a function. And finally, we get output. Now, this output may differ with this input. So we have an error and we try to reduce this error. These W's are called as the parameters, and this is what we need to tune basically. So every neural network is basically some sort of tuning algorithm. So this tuning, those who are old, means in 40s or above that, they might have that experience of even tuning the older TVs and the older FM say machines, where we need to tune those knobs to reach to a specific frequency. So a similar tuning is being done here. So these weights needs to reach to specific values in order to give the correct output by this neural network. And these weights and how these weights are basically tuned is what the neural network is. So we say that in one pass we go like this, and then we make a backward movement, what is called as the back propagation algorithm. And this back propagation algorithm basically tunes this weight. And this tuning will, if we go say frequently or say go a number of times, we will have more or less very good. But the problem here is, if we go, and what's the problem before advent of deep neural network? So this weights, sorry, the back propagation, when the back propagation, this weight tuning occurs, we need to create the gradient. So we need to create the delta values, and that gradient is basically something which passes from layer to layer. So consider this network. So if we get an error here, at this, so this is my y, and so the exact output say y, this is my y hat, say, and exact output is y, then y minus y hat will give me error. So this error I can only get at the last layer here. So once I get the error, I will back propagate what is the basically contribution of this weight in this error. So the important point is, if we are getting an error, our objective is to reduce this error to make it zero, which we never do. In fact, we make it very close to zero. Achieving zero is really difficult. So we want to make this E more or less equals to zero. So now if this error is coming, who is contributing or who is making this error? This error is made due to these weights, this weight, this weight, this weight, this weight, this weight. So every weight has contributed in this error. So this is the responsibility of all these W values which have made this error. So in order to reduce this error, these W's have to be adjusted. And in order to adjust that, we calculate the delta value, or basically the gradient, and we move in the backward direction. One by one, we change the W value. So we create a delta W or delta W new basically. Similarly, we create W new here by adding or subtracting some values from the old one. Now, and if we come here, again, we need to create one more derivative and multiply it with the previous one. Normally, if it is smaller than 1, so if say if this data value comes out to be 0.01, And at the next layer, again, it comes to be say 0.001 or say 0.02, something like this. If we multiply them, it will become even smaller number. And as we move on, basically, this number will become smaller and smaller. So it is after certain layer, you will find that due to due to the limitation of the computer, this number will become almost zero, exactly zero, in fact, after the precision has reached. So once it becomes zero, say at this layer, if it reaches zero, then after this, no weights will change basically, because W new will be W old plus minus delta value, and that value has become zero, so there won't be any change in these weights. So these weights will remain same. So we are only changing some of the weights. So that will not make our network. And that's what happened, or that's what had changed in deep neural network. People have come up with better functions which can basically restrict these values to reach zero. This problem is called as the vanishing gradient problem. It's a very popular problem in deep neural network. Vanishing gradient. And contrary to that, we also have an exploding gradient problem. So in exploding gradient problem, the reverse situation may occur. Say if we get a bigger value, say 3 here, 4 here, if we multiply and keep on multiplying, we will reach to a bigger value. So that is called as exploding gradient. Although exploding gradient is not an issue, but this vanishing gradient is a big issue. So this is what, so we have, people have tried so many ways. So once this deep neural network was in fact proposed, or they are started to be in use, in fact, it is the vanishing gradient problem we solved. Otherwise, everything else was more or less. Now coming to this modeling one, exactly how to model our problem. So we can have two different modeling approaches. One approach is called as the discriminative models. The other one is the generative model. In case of discriminative models, that's normally a classification problem. So what we do, given some value, or say given a sample X, we want to find out in which class this X belongs. So whether this X belongs to class 1 or class 0, say for example, if it's a binary problem. So we want to find out what is the probability of X. What is the probability of class, say class level, or say this 0 or 1. So what is the probability of Y? So that means we want to find out probability of 0 given X or probability of 1 given X. Meaning, if this X has been taken from some source, what is the probability that this X will belong to class 0, or what is the probability that this X belongs to class 1? So we want to find out this probability. This is a normal classification problem, or what we call as a supervised learning technique. The other model, which is called as generative models. So instead of putting this sample into this class, we say that, okay, there are two classes. Say there is a class and there is another class. So given a new sample X, what is the probability that this X has come from this class? That means this class has generated this. So if I can assume that there is a machine, so if there is a machine and this machine can generate samples from this class, and there is another machine which can generate samples from this class, sample for this class, then whether this X has been generated by this class or this X has been generated by this class. So given, so we want to find out the probability of X comma Y. What is the joint probability of X into Y? We call this model as generative models. So if we want to pictorially represent it, this is how a discriminative model looks. So we have data. So we want to discriminate them. So we can draw a line or some sort of curves in order to distinguish them. In a generative model, we want to find out the distribution of this class. What is the distribution of this class? What is the distribution of this class? And given a new sample, can this class generate that sample, or can this class generate this sample? And then we associate that sample with that particular class. So there are various ways of doing all these things. Since I will be moving on to generative adversarial network, so first I will start with an autoencoder, which is, you can say, a very simplistic form of that sort of generative modeling. So autoencoder is basically a neural network, and it learns an identity function in an unsupervised way. It reconstructs the original input. And in that process, it also compresses the data to give a more efficient and compressed representation. Let's see the network first. So this is the network. We have X, and the same input is also same. This is the input X, and you see the same thing has been given as output to this also. So input and output are same. And in between, we have a layer of network. So since it is an abstract notation, let me give you a better just so if I have a network like this, if I create a network like this, we may go something like this. So here I give some input, and then same input is also given here as output. So if I give X as output, the real output is also should be X, but we get an X prime. And these are all totally connected networks, so they are connected to each other. Okay, so what it learns and basically what it does. So we call this as the bottleneck. This is the encoder part, and this is the decoder part. So we have three components in this network: the encoder, the decoder, and the bottleneck. Now what encoder does? Encoder learns how to reduce the input dimension and compresses the input into encoded representation. The bottleneck layer represents or contains the compressed representation of the input data. Decoder basically reconstructs the original data from this bottleneck. And obviously in that process, as I told, that if we give X, it is expected to produce X, but it never produces X. It produces X prime. And hence X prime minus X will be the reconstruction loss. And then that loss has to be minimized by something. Where it is used, in fact, this autoencoder network has got a large number of applications like dimensionality reduction. So if you have huge number of features, say if you have 1500 or 1000 or 2000 features, you want to reduce it to say 100 or 200 number of features. So you can use an autoencoder of this nature. You start with say 1000, you make it 100. So ultimately your 1000 data will convert it to 100. So the data with 1000 representations or 1000 say dimensions will reduce to 100 dimensions. And then this 100 dimension may be used by decoder function to generate the original input. Anomaly detection: in most of the anomaly detection techniques, security algorithms, we use this sort of techniques, because then we say that, okay, we have a genuine system, and if it learns something or if it takes something which is different than the exact one, it detects. Image processing, popularity detection, machine translation, hate speech detection, spam review detection, these two we have worked, and they are shown in these references. So these two papers, we use this autoencoder technique to get this one. If you allow, I will just show you a demonstration exactly how we can create an autoencoder network for you. So this is a code, simple code you can see here. And you see the output first, and then I will come to the coding part. So in fact, this code has been run just for one time. So I have just run it for one iteration, and you see I have given 7, it produces 1 as output. But if I run it for 10 10,000 or 20,000 iterations, I can get exactly what has been given as input. So in a very, just I will go through this code. So here we have certain, we are using it in TensorFlow and Keras model. And then we are just using this MNIST data set. This is the shape of this data set. I'm not running this algorithm. In fact, these codes are running. If someone wants, I can share these codes. So this is how a network, basically an output will look like. This is something, and then we reduce it, we normalize it. So here we are normalizing it. After normalization, all this, say 200, 300 values will come to some 0 and 1 value. So between 0 and 1. So this is how it will look. And then this is the input representation, input filtering. Here I'm making my encoder model. So in encoder, you see that I'm creating an encoder, and this is the encoder. So we have 28, then we convert it to 14, then we convert it to 7. Then through a dense layer, I convert it to 16. So an input of size 28 cross 28 is ultimately reduced to size 16. And then in that process, I will use 69,008 weights. So I was talking about the weights in those neural networks. So in that process, exactly we are getting 69,008 weights. These weights needs to be tuned. Similarly, on a decoder part, you can see we start with 16, then we move on to 3136, then to 7, then to 1440, 28, 28, and this is the output. So this is exactly what I was trying to show you. So something we started with 28 cross 28 cross 1, then 14 cross 14 cross 1, then 7 cross 7 cross 1, then something, and then finally, so this comes to 16 only. So real input was 28 cross 28. It's a huge number. And later on, what we do, in fact, we remove this part. So once the network is trained, we basically remove this part. We can remove this part, and we can take from this, we can take the output as 60 neurons, and that will be my representation for this X. Later on, those inputs can be given to this decoder part, and we can reconstruct the original input. So this is the complete network. You can see the encoder, the bottleneck layer, and the decoder. And the loss function was Adam, the loss function was mean squared error, and optimizer was Adam. And we run it, as you can see here, I am running it for 1 epoch. And with 1 epoch, this is what I am getting as output. If I run it, if you really want to check it, exactly will it work, whether what I am claiming will work, yes, but you need to run it for at least 10 to 20,000 iterations in order to learn that exact representations. Okay, so that's how an autoencoder network works. So I'm skipping this mathematical notations basically. Then the next advanced version, people moved on basically or used. So one more application of this autoencoder is, in fact, in our mind also we have an autoencoder. So that's why once we see a face of a particular person, and next time after years, if we see that face, even some portion of that face, we can recognize it or her. Okay, this is that gentleman or gentle lady, or say this is how. So this, because we have an autoencoder, so we learn that representation, and that's we recreate by the decoder function. People also say basically tune this autoencoder, and then they created something called as denoising autoencoder. In denoising autoencoder, what people do, instead of the original X is given as output. So at output we get or we give the exact X, but at input we do not give the X. We basically disturb X. So some portion of the X is destroyed, and then the destroyed image or some things is given to the network, and then we ask the network to reconstruct this. And that's why, in fact, we have a various denoising autoencoder inside our mind. And that's why even a corrupted photograph or photograph which has been, say, damaged by something, that also we can recognize that this is this person. If some portion is hidden, then also we can recognize. So that is due to this denoising part. So the rest of the things remain same. Instead of giving the real input, we give a corrupted input, but at output we give the real input, and then we try to learn this function. And in that process, whatever autoencoder we get, we call that autoencoder as denoising autoencoder. Then there is a variational. People also say again moved on to this one and tried something else. Okay, can we make this autoencoder bit better, or say add something into this? Then people created something called as variational autoencoder. Now, variational autoencoder, exactly what it does, let me just show you this figure. So now we had, till now, what we were saying, okay, we have so say if I have got some input, say this is my, so this is my x, say x1, x2, and then say some y1, or say y2. So there are two different types of inputs I have. Then right now we were saying, okay, they will be mapped to some smaller version. So say if this x is of dimension 100, I want to reduce it to dimension say 30, then autoencoder was reducing everything to 30. That means corresponding to x1, we will have a say x30, x130, then similarly x230. This sort of features will be available in both the autoencoder as well as the denoising autoencoder. Now, if I say, can we create another space and we will map this x to some other value, say some sort of z, and which is of dimension 30. So that's where the variational autoencoder is. So that means we are not only reducing the size, we are also transferring this x from one space or one representation to another representation. So that's what the variational autoencoder is doing. So given this x, it is mapped to a latent space, we call it as, which is z represented here. And in order to do that, how this x will be mapped to this j? So people mostly try with some sort of say a generating function. Say we call it as a probabilistic encoder, and we use the the mean as well as the variance to approximate this x. So x will have a distribution, and the mean as well as the standard deviation of that x will basically give me a latent space. And from this latent space, I can select a vector, then give it to again the probabilistic decoder part, and the decoder part will give us the x what was there. In fact, this is the idea which is used in generative adversarial network, but with the help of one discriminator model. So just one thing, so just one point, Pulvar liberal divergence, because we are going to use two probability density functions and compare or similar to any other places where we want to compute how similar things are or how dissimilar things are. If two probability distributions are given to us, how to find out the similarity or dissimilarity between them? So basically this gives us dissimilarity. So given a distribution Q and given a distribution P, how dissimilar they are, this can be calculated with the help of a KL divergence. So KL divergence is basically how different P is from the Q. So that's what we calculate. And this is not cumulative, commutative. That means Q divergence P is not same as P divergence Q. They have a different divergence. So with this point, now I think we have set the stage for the generative adversarial network. So let's start exactly what is generative adversarial network. And exactly what can be done with the help of generative adversarial network. So consider that we have got certain points on a space and we want to generate some more points like this. So this is, if you consider it to be a game. So given the figure below, and there is a rule called as P data, and P data is a machine, or you can say an abstract thing, which has generated these points in this space. Now, I say your task, or everyone's task, is to create a different point X in this space, but it should look like that it has been generated by this P data only. That means in this space, I have to put a new point in such a way that that new point should not be different from this one. That new point should look exactly like it has been generated by the original point generator mechanism only. So if there is a machine which has generated something, so that machine has generated all this data. Now I'm creating, say, since we do not know that machine, so that machine is not with us. So we are trying to approximate, or we are trying to recreate another machine which will resemble, or which will basically create the task, or will generate something which is similar to that. So that's the task, and that's what generative adversarial network does. So before going that, what we do? So one simple way is we can create a mental model, say call it as P model. So our real model was P data. Now I'm creating a new model called as P model inside my mind. I'm restricting the space. You see that all the points have been captured here. Only the space I have reduced because there are so many blank spaces here. So I have reduced that. Okay, this is the space where P data has generated. So this is the area where the data generation should be done, because so normally everyone will try, no one will put a point here. Or if you ask 10 people, hardly there will be a people who will point a new point, or who will place a new point here or here or here. So they will always try to put something in this area only. And that's what the first thing this P model has done. It has restricted that area. Okay, this is the area, this is the small area. Then this P model will try to estimate how P data was working and how I can generate. So we have a data set of observation X, and we, as I told that, according to some unknown distribution, this data has been generated. So we have to create a generative model, P model, which will try to mimic this P data. If we achieve this goal, we can sample from P model to generate observations that appear to have been drawn from P data. But this P model should be such that it generates examples which should look like that it has been generated by the original model P data. But it's not a very good model if it is generating something which is already there. So if someone says, okay, I will generate a point on this one here. So that's not a very good model, because if you are just superimposing on that point, okay, I have generated something which is coming from that area. That's true, but that's not an impressive one. That's not the model what we are looking for. That is of no use, because that data point is already there. So we need to create some data point which looks like this, but not exactly this. So these are the points. It can generate examples that appear to have been drawn from P data. It can generate examples that are suitably different from the observation in X. It should be different from already existing one. It should not simply reproduce things that has already been seen. Then this model is of no use. So we call this, this is again a very popular word nowadays. Everyone talks about representation learning, and my whole talk, in fact, is about some sort of representation learning only. So given something, we are trying to create a representation of that one that is compact, that is small, so that later on we can use that representation to generate something, either that same sample or some different sample. So in autoencoder, we were generating the same samples, whereas in case of generative adversarial network, we will generate a different sample. So consider this sort of things. So if we have certain objects like this, we want to create a representation learning. Okay, the things will have some sort of, these are basically some sort of objects which is circular or which is say cylindrical in shape, the size and this thickness and then the length, breadth, etc. The model can be say suitably assumed. Say if these models or these data have been given to us, and if I have a model which can generate this sort of things, which looks like this, but obviously different from. So if whatever it has generated was not existing in that data, it has generated something new. And that's what the power of generative adversarial network is. Given these two images, although frankly speaking, right now, I have also forgot exactly which one is real and which one is fake. So one of the images is fake and one of the image is real. Similarly, in this one of the image is fake and one of the image is real. So it's really very difficult to differentiate that which one is a real image and which one is a fake image. So that's what the generative adversarial network is doing. Now coming to this GAN model now, I've taken a lot of time to explain or to come to this GAN model. So coming to this GAN model, so we have two different components now, you can see. One is the generator and discriminator, and that's where I started my talk, that we have two different types of modeling approaches, a generative modeling approach and a discriminative modeling approach. So discriminator is basically, you can assume that this is a classifier, basically. This is a simple classifier. And this is something you can say a decoder from that variational autoencoder sort of things. So if you just assume it to be a decoder, what we have already seen in case of variational autoencoder and different types of autoencoder. So say this generator is our decoder and this is a discriminator. And this is basically the encoded vector, the bottleneck what was there. So if you just see that variational autoencoder, in variational autoencoder, we were mapping it to a separate space. And say consider that, okay, we have that latent space here. So if we take some value, a vector from this latent space, and then based on that latent vector, and we add a noise. Why we add a noise? Because if we do not add a noise, then it will generate similar samples every time, which is again of no use. That's what we have already discussed. That if it is generating the same image again and again and again and again, that GAN model is of no use to us. So GAN models should give different images or different things at different times. So that's why we are adding a noise to this. And then this generator will produce something. So consider like, I will go with those popular examples of art stealing or say art examples. So art pieces or drawings or say paintings. Let me call it as painting. So say our generator is basically a fake painter who is generating fake printing or say fake painting. So this generator will generate fake paintings based on the latent space and certain noises. So it will generate a fake painting. So say F, and then it will send it to discriminator. Discriminator is that art inspector. So discriminator will check it and will say, first time if it is done by the generator, it will be a very bad nature. And obviously discriminator will easily say that, okay, this is fake. It's not a real painting, fake painting. So it will label it as fake. So it was fake and the discriminator will label it as fake. So as soon as the discriminator says it fake, the generator will come to know, oh, I have been caught. So that means I need to improve. So generator will improve on itself. So there will be a loss function. So you see this fine tuning. So there is a loss function. This with that loss function, it will try to improve on this. So these weight matrices will be basically updated. And ultimately they are neural networks, so there will be weights only. So these weights will be updated. Once these weights are updated, then again it will generate another sample, say F2. It will send it to discriminator again. So this time also discriminator comes to know that this is a fake and identified it as a fake. The generator will again do that. So generator will continue updating itself. A time will come when generator will generate something which is really looking like a real image or real drawing. Then when a new sample, say if J comes, and discriminator is not able to distinguish it. So discriminator says that this is real. Then the generator has come to know, okay, this is probably good enough. I have trained a bit, but somehow discriminator also improve on itself. It has to improve. Then what discriminator will do? So since if it is a training phase, there will be one feedback that, okay, discriminator, you have made a mistake. And then the discriminator will have certain real samples also, and discriminator will start again retraining. That means the discriminator will try to sample. So all these fake samples, what it has given so far, with the real, it will try to improve on this one. So this part there won't be any weight updation here, but there will be a weight updation here. Okay, so once these weights are updated into this side, again that same cycle will be repeated. Again the generator will generate some fake samples, send it to discriminator. The discriminator will again use its expertise and say if it is fake or not. If it says that fake sample is classified as fake, so it was fake and it says fake, that means it is the generator's time to update itself. And if it is fake, and a time will come, so this way it will continue. So you can see at one time stamp, basically the generator is improving or generator is fine-tuning itself. At another time stamp, the discriminator is improving or basically fine-tuning itself. So this cycle will continue. One by one, turn by turn, they will be updating itself. And a time will come when the discriminator will have a accuracy of around 50-50. That means whether it's real or fake, discriminator will not able to identify it properly. So at that particular time, we can stop, or even you can fix that the stopping criteria. So after a certain number of iterations, you can stop, you can remove these parts, and then you can say that, okay, my generator is now tuned. So this is this model. So what we were talking so far, no? So this P model, what we were trying to learn. So now this is our P model. So this generator is our P model, and the generator has now learned how to generate samples from this space. And that's how this generative adversarial network in general works. This was one of the basic idea of generative adversarial network. So notations, if you see mathematical, again, I'm skipping this one. This is the loss function. This is how we can basically, we have implemented in the pseudo codes. So you see here, so we load the data like if we use GNIST, say MNIST. So we create a network. So we create basically a discriminative network. Then we compile it with binary cross entropy, and we create another generative model. So we use the input noise and image. Then we combine both. So a fake prediction is G of noise D. So this is the fake prediction. Combined model is the combination of both, and then we compile the combined model. And every time, so in a loop, as I told, so they will be continuously going through. So we train either discriminator or we train the generator. So discriminator takes certain real images also because it has to. So if you see this figure, you might have seen that discriminator has access to certain real images. So it takes certain real image in order to learn it, okay, how real image looks like. So it samples real images and then it samples fake images from this generated data, and then it is trained on batch with the real images for class 1 and for fake images with class 0. And then the generator is also trained on the batch for noise and ones. So basically it want to create real images, and that's why we train it with ones. This also can have a problem, like as I told, vanishing gradient. It can have a impact in the GAN model also. So if the loss is 0, yielding no gradient to update the loss during learning addresses, as a result, training a GAN faces the dilemma. If the discriminator, the problems are, if the discriminator behaves badly, the discriminator is giving very bad results. The generator doesn't have accurate feedback and the loss function cannot represent the reality. So say here, generator is generating something, it is generating very bad fake images or fake paintings, but still it says that, okay, this is real painting. So if it is not giving the correct output, or not able to identify, the discriminator is very weak, you say, then the generator will not get the real feedback. And once it doesn't get the real feedback, obviously there is no point of improvement. So generator will not improve. And if the discriminator does a great job, the gradient of the loss function drop down to close to 0 and the learning becomes super slow or even jam. But if the discriminator does a great job, that means if the discriminator is really able to identify that this is a fake sample, then sometimes the loss function, the gradient becomes very close to 0 and learning becomes super slow or sometimes even stuck. There is another problem in GAN models called as mode collapse. Mode collapse is if the GAN model is producing same output every time. So whatever input you give, it is producing because it has seen that normally what happens, you think of a human being, that it has created a painting, a fake painting, and that fake painting was given to the discriminator, and discriminator identified it as real painting. So now the generator has come to know, okay, this painting is good enough. And hence next time it is again going to produce the same painting and or very similar painting and showing it to the discriminator. Discriminator will again say that, okay, this is a real painting. So in general, what happens with this generator is, discriminator is performing badly, no doubt, but the generator is not improving or it is not showing any variation in the result. So it is generating similar sort of paintings, fake paintings. So that is called as the mode collapse. The other problem what a generator may face is it fails to learn to represent the complex real world data distribution and gets stuck in small space with extremely low variety. And lack of a proper evaluation matrix, still not a good objective function that can inform us the training progress. So no good sign to tell when to stop, and no good indicator to compare the performance of multiple models. In order to get rid of some of these problems, different loss function, or in fact distance function was proposed. That distance function is called as Wasserstein's distance or earth mover distance. Now earth mover distance means it's like taking say soil or sand from one place and putting it to another place. So if we say that, okay, this is something given to us, and if we want to make this similar to this, so this is what has been generated, and this is what looks the loss right now, or the object has been created. We want to create something like this. Then what we need to do, we need to put something from this place to other places. Like this is quite big, this needs to be small. So we need to put some sort of soil, you can say, a sand from this area to this area, this area to this area. And if we consider each to be one box, so there are 3 boxes, there is 1 box. This 2 box has to be removed from this place. So that's what you can see here. 2 boxes have been removed from this place. So now this becomes similar to this. Then now this is bigger. So again, 2 boxes has to be replaced from this place. So these 2 boxes have been replaced. So these 2 become similar. And this is now, smaller, and this is basically a bigger one. So we need to move something from this place. So this sort of movements, so count of all these movements is defined what is called as earth mover distance. So you can see from this example. So defined as the minimum energy cost of moving and transferring a pile of dirt in the shape of one probability distribution to the shape of other probability distribution. 2 distributions P and Q each has 4 piles of dirt and both have 10 shovelfuls of dirt in total. The number of shovelfuls in each dirt piles are assigned as follows. So this is what we have. And you see, in order to change P to look like Q, we move first 2 shovelfuls from P1 to P2, then 2 from P2 to P3, then 1 from Q3 to Q4, sorry, P3 to and P4 to Q4. So if we count all these things, so that's basically what is called as the earth mover distance. So earth mover distance is found to be solving the problem of mode collapse. So this distance measure basically get rid of those mode collapses. So you can see here, finally the earth mover distance is this. As we know that given one technology, and if it is found to be good enough, people try a lot of other varieties and a lot of other changes into that one. So people have come up with deep convolution neural network, best GAN. So we have got deeper structure, more input noise vector, and passes it through a repeating setup of upsampling layers, convolution layer and batch normalization layers to stabilize the training. We do vector arithmetics like this is people have tried arithmetic in DC GAN, sorry. So you see that given certain images, man with glasses, and then man without glasses minus, if we subtract this and if we add women faces, then we'll get some figures of women with glasses. So this has also been achieved in DC GAN. Then we have a conditional GAN. So conditional GAN means if we want to generate samples of different types, then we can provide a conditional signal. So based on one input, basically the conditional GAN will generate the other types of different types of output. Okay, so that's all from my side. I know that I had to go a bit faster in order to stick to the time frame. But I hope I was able to convey the basic idea of this modeling approaches and so on.
Yes, sir. Yes, sir. Of course. Now, you took us to a journey. I would say you took us through the FDP and brought us to the classroom feeling. The moment you were drawing and then quickly opening up another application to make those boxes. And thank you very much. We are highly appreciative of it. And panelists, we thank him on your behalf as well. And we have got questions also, sir. We'll share that. Meanwhile, we have sent the attendance link and the feedback link for our participants. May we please request all of you, and don't worry about being, I would say if you were late for 10 minutes or something in the morning, the afternoon session that we started, we are having fruitful learning. So we have got some questions, sir. We'll be reading them one by one for you.
Sure. Yes.
And we have got 2 questions from our participant, Ankit Javeri ji. 2 questions, sir. I'll read both together. Now, the first question says, any best way to learn deep learning entirely while simultaneously understanding its mathematical concepts behind the same? And second question from Ankit ji is, can we adjust learning rate or any hypertuning parameters to its optimal value, such as the model doesn't lie in local minima, but at the same time, the gradient value doesn't diminishes to 0 or near to 0? I'm copying these 2 and sharing with you, sir, as well. Yes, sir.
Just forget the name of the professor. So there is a professor in University of Waterloo. I'm just I cannot recall his name. I have some lectures.
Mhm.
If someone is really interested to know the mathematics behind these deep learning models, I will suggest to go through his lectures. Please share. I will share the email. Say the name. If it, I have the lecture, so I need to check that. So I'm sorry that I'm not able to recall that. I think Ali Godsi something. Let me just try.
Ali Godsi, sir.
Yes. So
Yeah.
if really, so this is the Professor Ali Godsi. So those who want to learn the mathematical part, statistics part of deep learning and how things work really, what is the mathematics behind them? I will say, just you go listen. Say a lot of things I have gained from this gentleman. So I'm really very grateful to him for sharing all these lectures. Really a very good mathematical explanation. Those who are interested, please visit that. So yes, sir. This was the first one. I think there was another question.
I'll read the second question also, sir. For this, can we adjust learning rate or any hyper tuning parameters to its optimal value such that the model doesn't lie in local minimum, but same time the gradient value doesn't diminishes to 0 or near to 0?
See, the hyperparameter tuning itself is again a lot of papers are written into that. So you can note down all the hyperparameters what you are going to use, and then you can try the conventional techniques as well as the nature-inspired optimization algorithms. In fact, a lot of papers you might have seen, they are talking about optimizing the hyperparameters. So obviously it can be done. Now considering continuing to second part, controlling that if the gradient doesn't goes to 0 is really difficult thing to say control at that particular time. I'm sorry, I have never tried that, but obviously considering regarding the hyperparameter, we are doing a few works into that area.
Sir, thank you. And there's one more question. We have some participants who are into language and translation. Their research area
Yes.
is that. So one question from one of the participants, she's Pragya Tiwari, and she's asking, can we use this kind of training for translation as well?
Yes, people are trying. Say encoder decoder structure is the popular one in machine translation. Almost all machine translation algorithms systems what are state of the art today are based on the encoder decoder model. So there is a language part where normally the structure goes like this. So it goes say something like this. We have an encoder.
We don't have your screen, sir.
Sorry.
So we.
So normally
Yes, sir.
we have encoder. Sorry, my spelling is and the writing is not good on this one. And then so say if I'm trying to convert Hindi to English or English to Hindi. So I will give Hindi here, and normally the idea is again this Hindi language old text will be encoded into something, and then one by one I will give it to decoder. So it will be encoded first, and then it will be given to a decoder, and then we take output from this one. So output sentences are taken here, and input sentences are given here. So that's the usual structure in machine translation. I'm sorry again, I am not very good. I'm not working in the field of machine translation. So whatever idea I have, the state of the art is mostly something like this. So obviously, wherever there is encoder decoder, you can always think of GAN. In fact, one of my students has just implemented a GAN model for generating some sort of say hate-related speech so that we can train another models because the data set was scarce there. So, but that I have not yet checked. I have not yet. I cannot confirm that how good or bad it is working. So probably in future, if we meet, I can give some shed some light on that. Not today. I'm not very sure about that.
Yes, sir. Thank you. And we have got two questions from our participant, Professor Rajan Prasad Tripathi. How do we solve the problem of overfitting while using autoencoder, especially while using large number of neurons in each hidden layer?
Okay, so overfitting is basically if it is large number. So in most neural network, you use a dropout function. So that's the basic standard way of dealing with overfitting in a deep, or in fact any neural network, especially in deep neural network. So we use a dropout layers, so that you see everywhere you will get dropout. So what dropout does is it fuses the weights. So if we have, say, weights like if we have a neural network like this, say something like this, these are all connected, say like this. So if I use a dropout here and say dropout rate is fixed, so say dropout rate is 0.2. So what it does, it with a 0.2 probability, it makes this weight broken. That means this weight is made zero. So it is no longer. So you can say if this weight or this link is deleted. So that's how we deal with the overfitting in this deep neural network.
Yes, sir. Adding to this, there is one more question by him. Sir, how do we find the exact number of epochs to be run to get maximum accuracy?
That's something no one knows. So obviously it's a neural network. So we are expected, as I told, that this is some sort of tuning. So given some initial weight, we are trying to base it. The idea is, as I give, no. So what is the age? I do not know your age, but as sir can understand, we used to have certain knobs, and then we used to just note down or change those knobs to fix to a particular frequency. So that's the scenario. So given a weight, say the weight should be 10, and randomly when I started, the weight started with 2. Now I have to move from 2 to 10. So there is no fixed number of epochs, or no idea about how many epochs it will take to reach from this 2 to 10. So that's absolutely nothing can be, no one can say anything about that. So idea is in fact in modern neural network, there is an early stopping criteria. So you fix it to a bigger number. So if you have the computing capabilities or computing systems available, you make it quite big. So you fix it for say 1,000 iterations. As soon as the models checks and finds that in last 4 or 5 iterations there is no change, it will stop there. So it will not waste the resources. In almost all Keras model and TensorFlow models, even PyTorch models, we have that. So they stop at that particular early stopping criteria. But no idea can be made about the number of say epochs. I hope I am clear.
Thank you, sir. Thank you. We are asking participants one more time, if there are more questions from your side, just feel free to put it in Q&A. Any participant, if there is any query regarding your doubts, or you want to add on something, yes, please. If you have got something to say about the session, your observation to Dr. Jyoti Prakash Singh. Yes, so the extensive explanation, the demonstration, the queries must have resolved many doubts of the day, sir.
So it seems that there are no more queries.
Yes, sir. For now, no more questions, but we believe they'll be getting in touch, finding it out through the deep learning videos that you just said. I posted the link to the YouTube channel where we had Professor Ali on deep learning. And we are thankful to you, sir, for this thing. And we take this moment to put up a great thanks to you. I shall also put up this gratitude on behalf of everyone who joined the FDP and all of the participants who were also there with us. Thank you very much for being with us. Any observation or something like all the participants feel free. Thank you very much, everyone. So tomorrow we'll be meeting again in this International Faculty Development Program organized by Amity University in Tashkent. We are thankful, Dr. Jyoti Prakash Singh, for your time and all your insights. Thank you, sir. Thank you very much. So thank you, everyone. We look forward to meet you tomorrow. And tomorrow we have interesting sessions coming up. On day 2, we shall be having a session from the director, NIT Sikkim, Professor MC Govil, on smart future technologies in AI, ML, and data analytics, a detailed perspective. Session 3 will be tomorrow from 2 to 4:30. Tomorrow we'll be having one extensive session, and day 3 will again be bringing up more sessions. We look forward to have you again. Thank you very much for being with us. Good day to you.